The riverbank is black before it is anything else. Not empty black, and not silent black, but the heavy kind that gathers above warm water after the sun has gone down. A channel moves somewhere in front of you, slow and brown, carrying broken leaves, splinters of wood, and the smell of mud from a floodplain that will one day become Montana, North Dakota, South Dakota, and Wyoming. The banks are low. The ground is soft where the water has dropped during the dry weeks. In that softness, a three-toed print fills with reflected starlight. It is not fresh enough to hold the skin, but it is fresh enough to show the weight. A dinosaur crossed here at dusk. The mud received it without knowing that it was holding one of the last nights of the dinosaur world. There are no human lights anywhere in Hell Creek, no campfires, no roads, no town glow beyond the hills. The darkness belongs to animals that understand it through smell, vibration, warmth, and habit. Frogs call from the edge of a backwater. A turtle shifts against a submerged branch. Insects move in the leaves of flowering shrubs and under the fronds of ferns. Farther back from the channel, where the ground lifts into a drier rise, a broken tooth lies partly buried beside a root. It is curved, serrated, and dark at the edges, a small piece of a large hunger. By morning, silt may cover it. In 66 million years, a hand may uncover it. For now, it is just another hard object in the night. Hell Creek is often imagined in daylight because fossils are collected under daylight, photographed under daylight, and mounted in museum halls beneath steady lamps. Tyrannosaurus is shown with its skull turned toward a painted horizon. Triceratops stands in profile, horns lifted into permanent posture. Edmontosaurus is arranged as a skeleton, every rib cleaned of the floodplain that held it. But those animals did not live only in the hours that are easy for us to see. Their world had evenings, moonless nights, storms after sunset, and mornings when mist rose from the channels before the heat returned. A formation is a stack of sediments, but a living formation was also a sequence of nights. Each layer once had darkness above it. The Hell Creek Formation records the final part of the Cretaceous in western North America. The rocks were laid down near the end of the age of non-avian dinosaurs, roughly from about 68 to 66 million years ago, in terrestrial coastal environments as the western interior seaway retreated from the continent. The world here was warm and wet compared with the modern northern plains. Rivers crossed broad floodplains. Lakes, swamps, forested soils, sandbars, and levees shifted over time. Sediment buried leaves, bones, teeth, scales, shells, and fragments of animals that were too small to become famous, but too important to be ignored. This was not a single place frozen in a single year. It was a long landscape, changing as rivers do, with life arranged around water, seasons, and chance. If nights like this are why you return to Jurassical, subscribing simply keeps the next journey close. The ground we are entering is not a mythic battlefield. It is a real, late Cretaceous ecosystem, known from bones in badlands, teeth from microcytes, pollen in sediment, coal seams, mudstone, sandstone, and the thin boundary that marks the end of one world and the beginning of another. The animals here do not know they are late. They do not know their names will be made from Greek and Latin, or that children will later draw their outlines from memory. They know where the river is. They know when the air cools. They know the sound of something large moving through brush. At night, evidence becomes more difficult. Fossils can show anatomy, wear, injury, growth, diet, and sometimes even a moment of contact between predator and prey. They do not easily show an animal's hour of activity. A skull can preserve the size of the eye socket, and in some animals the bony ring that supported the eye may offer clues about light conditions. But reconstructing behavior from that evidence has limits. Some studies have suggested that Mesozoic archosaurs used all parts of the day and night, with large herbivores possibly active at intervals, and some predators at least partly active in low light. Other researchers have urged caution. So we should not turn Hell Creek into a fully nocturnal world. We should only allow night to enter it, as it must have entered every living day. A Triceratops does not need to be a creature of darkness for it to move after sunset. Large herbivores often divide their time between feeding, resting, drinking, watching, and shifting position as temperature and insect pressure change. In Hell Creek, a horned dinosaur standing under the dim light would still have been a horned dinosaur, heavy, low-headed, muscular across the shoulders, with a skull that could reach more than 2 meters in length. The frill would have changed the shape of the animal in silhouette. The brow horns would have made the face look longer than the body seemed ready to carry. When it lowered its beak to crop leaves from a shrub or strip low growth near the water, the mud at its feet would have pressed around broad toes. Triceratops was not a rare ornament of this landscape. In many Hell Creek collections, ceratopsian remains are among the most common large dinosaur fossils, and that abundance matters. It means this animal was part of the normal working structure of the ecosystem, not an occasional visitor wandering through someone else's world. It shaped vegetation by feeding. It provided food after death. It left bones large enough to survive weathering and burial. At night, a group may have gathered near a river bend, or solitary individuals may have spaced themselves across the floodplain. The exact social pattern is still debated. The rock gives us skulls, horns, frills, jaws, and postcranial bones. It does not give us every choice an animal made. Somewhere beyond them, Tyrannosaurus is present even before it appears. The presence is not a roar. Fossils do not preserve roars, and most animals do not announce themselves when they want meat. It is a pressure in the system, a reason for alertness, a reason for young animals to stay close to cover or to adults. Tyrannosaurus rex lived at the very end of the late Cretaceous, and Hell Creek is one of the places where its bones have made it real. Its teeth were thick, not delicate blades. Its skull was built for force. Its sense of smell appears to have been important. Its forward-facing eyes gave it depth perception. Whether it killed a particular animal or arrived after death would have changed from moment to moment, meal to meal. Predators are rarely one thing. The old argument that Tyrannosaurus must have been either hunter or scavenger is too simple for a living animal. A large carnivore with teeth, legs, eyes, smell, and opportunity would not ignore a carcass because it preferred a chase, and it would not ignore vulnerable prey because it had once found something dead. In Hell Creek, carcasses mattered. A dead Edmontosaurus on a riverbank would draw insects first, then smaller scavengers, then larger ones if the scent carried. A tyrannosaur could feed from a body already opened by decay or by another animal, and it could also leave its own marks on bone. Teeth enter the fossil record in ways intentions do not. Before the animal itself arrives, the smaller knight is already busy. A multi-tuberculate mammal noses through leaf litter with a body built close to the ground. Another small mammal pauses under a fallen branch, listening. The mammalian world of Hell Creek is not the future yet, but it is not insignificant. These animals live in the margins of giant bodies, among roots, burrows, logs, and patches of cover where a large dinosaur cannot place its feet easily. They eat insects, seeds, soft plant matter, perhaps small vertebrates depending on the species. Their teeth are tiny compared with a tyrannosaur tooth, but in microsites they can be more common than the bones that museum visitors gather around. Microsites are important because they change the scale of the story. A famous skeleton can make an ecosystem feel as though it belonged only to its largest animals. But when sediment is carefully searched, washed, screened, and examined, it yields small teeth, vertebrae, scales, jaws, and fragments from fish, amphibians, lizards, turtles, crocodilians, mammals, birds, and dinosaurs. These pieces are not decorative background, they are the food web. A river channel full of gar, bowfins, turtles, champsosaurs, crocodilians, and small mammals is not a stage beneath Tyrannosaurus. It is a living system, and the large dinosaurs move through it, because the smaller life makes the place function. At night, the river is the most reliable road. It carries signals farther than open ground does. A fish breaks the surface, and the ripple moves into reeds. A crocodilian waits with only its nostrils and eyes above the water, not exactly the same as a modern alligator, but close enough in posture to make the comparison useful. A champsosaur, long-snouted and river-bound, moves through the dark shallows. Turtles rest against logs. Somewhere, a salamander or frog uses the damp margin where the mud has not yet hardened. Their bones, when they fossilize, rarely become symbols of an age, but Hell Creek without them would be a landscape with the mechanism removed. The plants are not the plants of the Jurassic world. By Hell Creek time, flowering plants have entered the forests and floodplains. The old Mesozoic greens remain in places: conifers, ferns, horsetails, cycads or cycad-like plants. But angiosperms are now part of the scenery, bringing leaves, seeds, fruits, and ecological relationships that earlier dinosaur worlds did not have in the same way. The Cretaceous night carries the smell of wet bark, decaying leaves, resin, open mud, and water plants pressed by current. Forests grow on better drained ground. Swampier areas gather darker sediment that can become coal. Floods tear through the system, and then plants return to the fresh silt. A floodplain is a place that remembers disturbance. Channels migrate. Banks collapse. Crevasse splays spread sand across low areas. Fine mud settles in quiet water. Roots penetrate soil, and later, another flood cuts through the same place. This is why Hell Creek is not made of one clean sheet of rock. It is mudstone, sandstone, siltstone, carbonaceous layers, and local accumulations that reflect a landscape repeatedly taken apart and rebuilt by water. To an animal, that means paths change. Waterholes appear and shrink. Dry ground becomes mud. A nesting place that seemed safe one season may be too exposed the next. Fossilization depends on this instability. A body left on high ground disappears. A body buried by river sediment has a chance. Night also changes risk. A young Edmontosaurus feeding near a channel may benefit from darkness if a predator sees less clearly, but darkness can also hide the predator's approach. Edmontosaurus was one of the great hadrosaurids of the latest Cretaceous, a broad-bodied herbivore with a long skull, a keratinous beak, and dental batteries that could process tough plant material more efficiently than earlier herbivores with simpler teeth. It was not a helpless animal, and an adult was large. But juveniles, sick individuals, and animals forced into bad ground by water or panic would have been vulnerable. A herd at night is not a peaceful mural. It is a shifting pattern of bodies, breathing, chewing, listening, and sudden stillness. The sound of a large hadrosaur moving through wet vegetation would not be delicate. Stems break, feet press water from mud, a tail brushes leaves, the head lowers and lifts with the rhythm of feeding. Dental batteries work deep inside the jaws, where rows of teeth are replaced as they wear, keeping the mouth useful across a lifetime of grinding. In the darkness, the animal is not the skeleton we know from museums. It is warm mass, muscle, gut fermentation, skin, breath, and decision. Its bones are only the part of it that will be allowed to continue speaking. Fossils show that Hell Creek contained more than the famous trio of Tyrannosaurus, Triceratops, and Edmontosaurus. Ankylosaurus was there, though its remains are less common. Pachycephalosaurs were present, represented by domed skull material and related forms whose taxonomy has been debated. Small theropods, including dromaeosaurids and other maniraptoran dinosaurs, left teeth and bones that hint at a faster, lighter predatory world under the larger one. Oviraptorosaurs such as Anzu are known from Hell Creek and neighboring deposits, showing that feathered, beaked, long-limbed dinosaurs still moved through these final Cretaceous landscapes. The last dinosaur world was not simple. It was crowded with lineages that had been evolving for tens of millions of years. Imagine Anzu at the forest edge after sunset, not as a monster, but as an animal with a body plan strange to modern eyes. Tall, feathered, long-legged, with a toothless beak and arms that carried traces of deep dinosaur ancestry. Its exact habits are reconstructed from anatomy and context, not from observation, but an omnivorous life is plausible. Eggs, small animals, plant matter, whatever the beak and hands could manage. Under low light, it may have moved along the margins where open ground met cover. If it left tracks in mud, a flood could erase them before morning. If it died in the right place, parts of it might enter the record and become evidence of how varied Hell Creek really was. The name Hell Creek makes the place sound cursed, but the ancient environment was not hell to the animals that belonged there. It was home. The harshness comes from our knowledge of the end, from the fact that every scene is shadowed by the boundary above it. A Triceratops drinking under starlight does not know that a thin clay layer will divide its world from the one that follows. A small mammal searching under leaves does not know that its kind will inherit ecological space after a catastrophe. The land is not waiting dramatically. It is simply continuing. That is part of what makes the final days difficult to imagine honestly. The Cretaceous-Paleogene boundary is one of the most studied divisions in Earth history. Around 66 million years ago, a large asteroid struck near what is now the Yucatan Peninsula, producing the Chicxulub crater and contributing to a global extinction that ended the non-avian dinosaurs. The boundary layer is associated with enriched iridium, shocked minerals, spherules, and other evidence of impact. In Hell Creek country, the transition from dinosaur-bearing beds to the overlying Paleogene rocks has been studied for decades because it preserves the world before and after the event in terrestrial sediments. The boundary is not just an idea. In some places, it can be approached as a physical line in rock, but before that line, there were nights. Thousands of them. Wet season nights, with warm rain hammering leaves and filling side channels. Dry season nights when mud cracked around shrinking pools and animals came from farther away to drink. Moonlit nights when the river shone pale between black banks. Clouded nights when everything became smell and contact. The last days of the dinosaur world were not a single mood. They were ordinary to the creatures inside them, and the ordinary is where most of life happens. A tooth falls, a branch breaks, a hatchling hides. A sick animal lies down and does not stand again. Consider a Hell Creek hillside in the modern Badlands. It is cut by erosion, colored in grays, browns, and dull reds, with slopes that crumble underfoot. A fossil hunter sees bone weathering from the surface. It may look like a dark patch, a curve with a texture different from stone, a fragment that has not broken like the surrounding sediment. That fossil began as part of a body under a Cretaceous sky. Between those two states lies burial, mineralization, compaction, uplift, erosion, and discovery. The night we imagine is not invented from nothing. It is built from the physical fact that bones and teeth were once inside living animals, and those animals moved through hours no one watched. In the darkness, the heat of the day leaves slowly. Hell Creek was warmer and more humid than the modern exposures suggest, but it still had changes in weather and season. A coastal plain near a retreating inland seaway is not uniform. There are low areas where water stays, higher levees that dry more quickly, ponds that collect organic matter, sandy channels that cut through mud, and forest patches that grow differently depending on drainage. For a dinosaur, these differences are practical. One place gives food. Another gives cover. Another gives water. Another preserves footprints for a few hours before the next rain collapses them. A tyrannosaur moving at night does not need to run to be frightening. The animal is too large for the forest to ignore. Its feet compress sediment deeply. Its tail balances the body behind the hips. The skull moves low enough to investigate scent near the ground, and high enough to look across vegetation. The teeth are not exposed in a permanent snarl. They sit inside jaws that open when feeding, biting, testing, carrying. The animal may pause at a carcass whose odor has strengthened since sunset. It may lower its head and pull. tendons give. The body shifts. Smaller scavengers scatter, then edge back when the giant lifts away. Bone surfaces can preserve feeding traces. Bite marks, punctures, scraping, crushed regions, and tooth fragments provide evidence that carnivores interacted with carcasses or prey. Interpreting those marks requires care. A tooth score on a bone does not always say whether the animal was killed or scavenged. It says contact happened. Sometimes that is enough. Paleontology is often the science of enough. Enough of a jaw to identify a mammal. Enough of a tooth to place a theropod. Enough pollen to reconstruct vegetation. Enough sedimentary context to recognize a river channel. The rest is built through comparison, probability, and restraint. Under a log, a mammal waits for the giant's footsteps to pass. Its world is measured in smaller distances. A hollow root, a patch of insects, a seed husk, a tunnel used yesterday. The mammal's night is not the same night as a Tyrannosaur's. The light level may be the same, but the scale is not. For the mammal, a turtle shell is a wall, a fallen leaf is cover. A dinosaur track can be a damp depression with trapped water and small invertebrates. These animals are not rehearsing for the Cenozoic. They are surviving the Cretaceous on its own terms. Scale is one of the difficult truths of Hell Creek. A single Tyrannosaurus tooth can be longer than the skull of a small mammal. A Triceratops skull can be large enough to dominate a room. An Edmontosaurus femur can carry the memory of an animal taller than a human at the hips. Yet the same formation holds fossils measured in millimeters, pieces that require screens, microscopes, and patience. The ecosystem was not arranged by our attention. It did not care which animals would become logos, toys, or film creatures. It distributed life according to food, water, reproduction, risk, and the long inheritance of evolution. Not every night in Hell Creek would have held Tyrannosaurus near Triceratops. Fossil formations compress geography and time in ways imagination can forget. A species list from a formation is not a single gathering. Some animals lived in different habitats within the landscape. Some may have been separated by thousands of years. Some were common, others rare. The living arrangement was not a museum mural where every named animal stands in one clearing. Still, the overlap is real enough to speak carefully. These animals belong to the same regional world, the same final Cretaceous coastal plain system, the same broad interval before the boundary. A river bend at midnight gathers many times into one image. On the inside of the bend, sand forms a low bar. On the outside, the current eats into the bank. Roots hang where soil has been cut away. A dead branch turns slowly in the water, caught and released by the current. Tracks cross the damp zone at different angles, wide, blunt impressions from a heavy herbivore, smaller three-toed prints from a lighter dinosaur, the drag of a tail or belly from a reptile near the shallows. Some tracks will dry and crack, some will fill with silt. Most will vanish. A few, in the right sequence of mud and burial, may become trackways. Tracks are a different kind of fossil from bones. A skeleton records the body after death. A track records a living moment. It shows weight, movement, substrate, and sometimes behavior that bone alone cannot. In Hell Creek and equivalent late Cretaceous deposits, footprints are less iconic than skeletons, but the principle matters. The ground itself can become a document of passage. A nighttime track is not visibly different from a daytime one, unless context suggests otherwise. Yet the idea reminds us that every fossil footprint was made at a specific hour, under a specific sky, while an animal was doing something ordinary enough to leave only a shape in mud. Above the floodplain, the stars would not be our constellations in quite the same way. The stars themselves would be mostly familiar in deep astronomical terms. But the slow movement of Earth's axis and the long span of time would change the sky's arrangement from any human pattern. No one in Hell Creek names the stars. No eyes look up and make mythology from them. A pterosaur may cross the last light before full dark, if the local habitat supports it. Birds, true avian dinosaurs, are present in the wider late Cretaceous world, and small bird fossils are known from Hell Creek region deposits. The sky is no longer the exclusive country of pterosaurs. By the end of the Cretaceous, birds were already a varied group, though not yet the dominant modern radiation that would follow the extinction. Some lineages lived along water. Some had teeth. Some flew with anatomies still carrying deep theropod history. Their bones are delicate and preservation is uneven, so the record is incomplete. But their presence changes the feeling of the last dinosaur world. Non-avian dinosaurs still dominate the land, yet avian dinosaurs are already there, moving through air and shoreline habitats, holding the future without knowing it. After the impact, not all dinosaurs vanish. The birds continue. That is why the phrase "last days of the dinosaur world" needs care. It was the last days of the non-avian dinosaur world, the last days of Tyrannosaurus, Triceratops, Edmontosaurus, Ankylosaurus, Pachycephalosaurus, and the other lineages that did not cross the boundary. But it was not the last day of Dinosauria. Birds would carry the clade into the Paleogene and into the present. A modern sparrow is not a metaphor for a dinosaur. It is a surviving branch. In the Hell Creek night, that survival is not obvious. The animals that will endure are smaller, more flexible, and less likely to dominate a mural. A small bird settling into cover near a channel does not look like the future. It looks vulnerable. Its bones are light. Its body is warm. Its world is full of mouths. If a branch shakes, it must decide whether to stay still or move. If insects gather near water after sunset, it may feed. If a storm rises, it must find shelter before wind breaks through the canopy. The future of dinosaurs is not carried by the largest skull in the ecosystem. It is carried by bodies light enough to hide and adaptable enough to find food after the sky changes. Storms matter in Hell Creek. A warm coastal plain near a seaway would have known heavy rain, swollen rivers, and sudden changes in water level. At night, a storm would erase boundaries. The channel climbs its banks. The floodplain becomes shallow moving water. Small animals climb, swim, or drown. Nests in low areas are lost. Carcasses shift. Bones are lifted from where they fell and carried downstream. Sand and mud move over everything. The same violence that kills can preserve. A dinosaur buried quickly by sediment has a better chance of entering the fossil record than one left on dry ground under sun, insects, and scavengers. This is why formations like Hell Creek are records of both life and geological sorting. The fossil record is not a census taken fairly across the landscape. It favors hard parts, rapid burial, and environments where sediment accumulates. It loses soft tissue, rare animals, fragile bones, and behaviors that leave no durable trace. When we speak of abundance, we speak through the filter of preservation and collection. Even so, patterns remain meaningful. Repeated discoveries across many sites show that certain animals were truly important members of the ecosystem. Triceratops was not invented by preservation. Tyrannosaurus was not an accidental visitor. Edmontosaurus was not a footnote. The rocks keep bringing them back. The floodwater drops before dawn. Mud shines around exposed roots. Fish are trapped in shallow pools until the next channel reconnects them, or the sun removes the water. A young turtle pushes through floating debris. Leaves plaster against the bank. Somewhere, a nest has failed. Somewhere else, eggs remain safe because they were laid higher, or because the water did not reach them, or because luck is often the difference between lineage and loss. Fossils can preserve eggshell fragments, nests in some formations, and embryonic bones in extraordinary cases, but for Hell Creek, many reproductive details remain harder to know. Still, every population here depended on successful reproduction. The last world was full of young. A hatchling Triceratops, if we imagine one cautiously, would not be a miniature museum skull with horns ready for display. Young ceratopsians grew into their ornaments. Skulls changed shape. Horns and frills developed through growth, and the fossil record of juvenile material helps scientists understand that transformation. A young animal at night would be low, alert, and dependent on choices made by adults or by its own instinct. Its bones would be thin compared with those of an adult. Its survival would depend on avoiding mouths large and small, on finding food, on enduring seasons, insects, disease, and floodwater. Growth is one of the quieter ways fossils speak. Bone histology can reveal growth rates. Ontogenetic series can show how skulls and bodies changed through life. A dinosaur species is not represented only by its adult form, even if adult forms dominate public imagination. Hell Creek animals hatched or were born, grew, changed proportions, suffered injuries, replaced teeth, wore joints, and died at different ages. A population is made of all those stages. At night, that means not one kind of Triceratops, but many sizes. Not one Tyrannosaur, but juveniles, subadults, and adults with different abilities and possibly different ecological roles. Juvenile tyrannosaurs were not simply small versions of the largest adults. Their bodies were more gracile, their legs proportionally long, their skulls less massive. This raises the possibility that younger individuals hunted differently from mature adults, pursuing smaller or faster prey before growing into the bone-crushing power of the adult skull. Fossils do not allow us to watch that transition directly, but anatomy suggests a changing life. In a night scene, a subadult tyrannosaur might be a different danger than a full-grown adult. Quicker, lighter, more likely to test prey that an older animal would ignore, still learning the edges of risk. An adult Tyrannosaurus, by contrast, is a convergence of mass and precision. The skull is immense, but not crude. Openings reduce weight. Sutures and bone surfaces distribute stress. Teeth are replaced as they break or wear. The neck is muscular, built to move the head as a feeding instrument and weapon. The legs support an animal that may weigh several tons. Its arms are short, but short arms are not evidence of weakness elsewhere. The animal is not designed to fit human expectations of elegance. It is designed by selection to function in its world, and for a long time, it did. In the dark, even a giant has limits. It cannot be everywhere. It cannot eat without finding food. It cannot avoid injury forever. A horn through soft tissue, a kick from a large herbivore, a fall on bad ground, an infection from a bite, a broken rib, a damaged foot, any of these can change a predator's life. Fossil skeletons sometimes preserve healed injuries, fused bones, pathologies, and tooth marks that remind us ancient animals were not symbols. They were bodies under stress. Survival was not automatic because a species was powerful. It was negotiated, day by day, night by night. Somewhere in the trees, a smaller predator takes a different kind of chance. A dromaeosaurid follows movement near the leaf litter. Its body is feathered, its balance quick, its hands and feet built for grasping, slashing, and holding. The exact species and their full appearances are incomplete from Hell Creek material, but small Maniraptoran predators were part of the system. They would have lived in the spaces between giant events, hunting lizards, mammals, young animals, insects, or carrion, depending on anatomy and opportunity. Their nights would have been fast and close to the ground, full of small sounds. The Hell Creek fauna also included animals that complicate any simple dinosaur-focused picture. Crocodiliforms were present, not as background reptiles but as important predators and scavengers in water and along banks. Champsosaurs, long-bodied aquatic reptiles with narrow snouts, occupied river and swamp habitats. Turtles were diverse. Fish filled channels and ponds. Amphibians used wet margins. Lizards and snakes, or snake-like records depending on locality and preservation, belonged to the smaller vertebrate community. Each group interacted with dinosaur life in practical ways. Eggs, hatchlings, carcasses, dung, insects attracted to dung, and plants browsed by dinosaurs all connected the large and small systems. Dung itself matters. Coprolites, fossilized feces, can preserve evidence of diet that bone alone cannot. A large carnivore coprolite may contain crushed bone fragments. Herbivore dung can carry plant remains, pollen, and traces of the digestive passage. It is not glamorous evidence, but ecosystems are not built from glamour. They are built from feeding, digestion, decay, recycling, and growth. At night, insects gather where dung lies warm. Small animals search through it. Seeds may pass through bodies and enter new ground. The record of Hell Creek is not only skulls, it is the entire movement of matter through living systems. Picture a forest margin after a humid sunset. The tallest trees stand as black columns. The understory is a mixture of flowering shrubs, ferns, young trees, and fallen logs. Vines or climbing plants may be present in some areas, though exact plant communities vary across local environments. Leaves drip after an evening shower. A hadrosaur's path opens a gap through the vegetation. Smaller animals use the same passage because a large body has cleared it. A tyrannosaur may use it too, not because it is thinking like a human trailmaker, but because animals often follow the easiest route through difficult ground. The Western Interior Seaway had been retreating during the latest Cretaceous, and that retreat helped shape the landscapes preserved by Hell Creek and nearby formations. Below Hell Creek, marine and nearshore deposits record the seaway's presence. Above, the Fort Union Formation records Paleogene environments after the extinction. Between them lies the terrestrial world of floodplains, rivers, lakes, soils, and forests. This stratigraphic position is why Hell Creek matters so much. It sits at the end of the dinosaur-rich Cretaceous record in this region, close enough to the boundary to make every fossil feel like testimony. Yet, testimony is not prophecy. A Triceratops horn weathering from a hillside does not tell us that the animal sensed doom. A Tyrannosaur tooth below the boundary does not mean the species was already aware of decline. Scientists debate patterns of dinosaur diversity leading into the extinction, and the answer may differ by region, sampling, and group. Some data suggest Hell Creek dinosaur communities remained ecologically substantial until near the end. Other work explores changes and biases in the record. The honest image is not a tired world waiting to die, but a living one still doing what living worlds do. That may be the most haunting part. The final nights were not empty. They were full of insects against leaves, fish in channels, turtle shells in mud, mammals under logs, horned dinosaurs cropping vegetation, hadrosaurs chewing, tyrannosaurs testing the wind, young animals following adults, and plants growing in sediment that had been disturbed 100 times before. Extinction did not arrive because life had become weak enough to deserve it. It arrived as a planetary event into a world that still had structure, abundance, and momentum. The Chicxulub impact was not local to Hell Creek, but its consequences were global. The impact released enormous energy, excavated a crater around the Yucatan region, and sent material into the atmosphere. Fires, darkness, cooling, acid rain, collapse of photosynthesis, and disruption of food webs are all part of the broad scientific picture, though details continue to be studied and refined. For Hell Creek, far from the crater but connected by atmosphere, ocean, and climate, the disaster would have arrived through shaking, fallout, darkness, and ecological breakdown rather than through the crater itself. The last dinosaur world was not ended by a local predator, disease, or storm. It was interrupted from above. Before that interruption, there is one more ordinary night to imagine. A channel under a cloudy sky. A bank softened by recent rain. A Triceratops track partly filled with water. A hadrosaur herd bedded beyond the levee, some standing, some resting. A tyrannosaur moving along the downwind side of the water, not rushing, because hunger is patient when the night is long. A mammal under roots, still and listening. A bird in cover. A crocodilian waiting where a side channel narrows. Plants breathing in the dark, releasing moisture, holding the soil that will later collapse into the river. No scene can contain all of Hell Creek. The formation stretches across space and time, and every reconstruction is a narrow window opened from scattered evidence. But a window does not have to show everything to be valuable. Through this one, the night gives us a way to remove the museum lights and return the animals to uncertainty. We see less, and because we see less, we remember that they lived without being fully visible to us. Paleontology is always partly an act of careful darkness. Something is there. You can touch its edge. The full body must be rebuilt with patience. The word last can make us compress 2 million years into a countdown. Hell Creek was not 2 million years of animals checking the sky. It was generation after generation. Tyrannosaurs hatched, grew, hunted, scavenged, aged, and died. Triceratops populations changed through time. Rivers shifted. Plant communities responded to climate, water, and disturbance. Small mammals diversified in their small ways. Crocodiliforms bred in warm water. Fish spawned. Birds nested. Some species appeared earlier in the formation, and others later. The last days were only last because we know where the line will be drawn. A fossil does not know the line either. It lies where deposition placed it. A bone just below the boundary belongs to before. A leaf impression above belongs to after. Between them, geochemistry changes. Faunas change. Diversity collapses and recovers in new forms. The boundary is thin compared with the thickness of life around it, but it is one of the most consequential thicknesses on Earth. In a hand sample, it may be only a clay-rich seam, a dark band, a change in texture. In the history of life, it is the door that closed on Tyrannosaurus and opened wider for mammals, birds, and flowering plants. The Fort Union Formation above Hell Creek contains Paleogene ecosystems that look different because they are different. Non-avian dinosaur fossils are gone. Plant communities were disrupted and then recovered. Mammals begin a long expansion into ecological roles that had not been open to them in the same way. Crocodiliforms, turtles, fish, amphibians, and birds continue in altered worlds. The sediment does not stop recording. Earth does not stop making layers because a famous lineage disappears. Rivers keep moving. Forests return. New leaves grow over old extinction. For the animals that failed to cross, there is no recovery. A species cannot experience its own extinction as a concept. It disappears through individuals failing to leave enough descendants. The last Tyrannosaurus did not know it was the last. The last Triceratops did not stand at the boundary like a monument. They would have been animals under stress, searching for food in a darkened, damaged world, with plant productivity collapsing and food webs unraveling. The true end may have been quieter than the impact itself. Hunger, cold, failed nests, fewer young, fewer calls, fewer tracks on wet ground. The impact darkness is different from night. Night is expected. Bodies are built around it. Plants, insects, reptiles, mammals, birds, and dinosaurs all live with cycles of light and dark. Impact darkness breaks the cycle. It reduces sunlight beyond the normal rhythm. It affects photosynthesis, temperature, food, and timekeeping. A Hell Creek animal could understand sunset because sunset had always ended. It could not understand a world where daylight weakened and did not return properly, where plants faltered, where the base of the food web began to fail. That is not night as habitat, it is night as catastrophe. Still, we should not rush there too soon. The title holds the last days, but the living world deserves its full length before the end. Return to the river. The stars are out now, between cloud bands. A line of hadrosaurs moves toward water, their bodies dark against a paler opening in the trees. One pauses with its head raised. Another continues feeding. A juvenile steps where an adult has already broken the mud, using the deeper print as an easier place to place its foot. Behind them, insects lift from wet leaves. The whole scene is practical, not theatrical. Animals use what other animals change. A Triceratops may arrive later, not because the night demands a meeting, but because water draws bodies. Its beak works at low vegetation near the edge. Its teeth slice and grind in a battery different from a hadrosaur's, but still effective for its feeding style. The frill may carry scars, vascular grooves, and evidence of growth. The horns are not just weapons in a duel imagined for spectacle. They are parts of a living skull used in display, defense, species recognition, and whatever social behavior ceratopsians practiced. In dim light, they widen the animal's presence. Ceratopsian skulls changed dramatically through growth, and those changes can mislead taxonomy if juveniles and adults are treated as different species without care. Hell Creek has been central to debates about ceratopsian diversity and growth, including the relationship between Triceratops and forms once separated more strongly. The details are technical, but the broader lesson is simple. Fossils are not static icons. They belong to life histories. A young skull, an old skull, a damaged skull, and a skull altered by compression can all tell different parts of the same biological story. The night contains those ages together if the population is healthy. Across the floodplain, a dome-headed dinosaur browses or moves through cover. Pachycephalosaurs are among the more puzzling Hell Creek animals because their skull roofs preserve better than many parts of their skeletons, and because their growth stages have generated debate. The thick dome is easy to make dramatic, but its function is still discussed. Display, species recognition, combat, or some mixture. At night, the dome does not need to become a weapon to matter. It is a surface of bone carried by an animal making choices in a crowded landscape, feeding, avoiding danger, and leaving only fragments behind. Ankylosaurus is even harder to place in a night scene because the animal is famous but not known from abundant complete remains. Its armor, broad body, and tail club make it one of the most distinctive dinosaurs of the final Cretaceous. It likely moved through low vegetation as a heavy, protected herbivore. An adult would have been difficult prey for many predators, not because it was invincible, but because attacking armor and a clubbed tail is dangerous work. In darkness, such an animal might be heard before it was seen, moving slowly through plants, body low, armor catching faint light along the back. The body of Ankylosaurus turns the problem of survival into architecture. Bony plates embedded in skin, a wide torso, a skull armored in its own way, a tail ending in a mass capable of delivering force if swung well. Evolution produced many herbivore strategies through the Mesozoic: size, speed, herding, horns, frills, spikes, armor, concealment, and reproduction in numbers. Hell Creek contains several of them at once. That is part of its richness. It is not the world of one dinosaur. It is the world of many solutions tested against the same pressures. The pressures were not only predators. Drought, flood, disease, parasites, competition, heat, seasonal food changes, and accidents shaped survival. A large dinosaur could starve if teeth failed, or if drought concentrated too many animals around limited resources. A young animal could die from exposure after a storm. A predator could lose a meal to another predator or to injury. A riverbank could collapse under weight. A carcass could nourish dozens of species. Ancient ecosystems were not less complicated because they were old. They were complicated in ways we can only partially recover. Night makes that complexity feel closer because it removes the clean outlines. In daylight, we separate animals by shape. Horned dinosaur here, duck-billed dinosaur there, tyrant predator behind them, armored form near the forest. In darkness, bodies become sounds, smells, and disturbances. The riverbank records weight without naming it. Leaves move before the animal is visible. A breath becomes vapor only if the air is cool enough. Water closes over a footprint at the edge. The world is less like an illustration and more like a place. A tyrannosaur's approach changes the behavior of everything around it, even if no chase happens. Smaller animals freeze, birds move to higher branches or remain still. Hadrosaurs lift heads. A Triceratops turns enough to bring its horns into a useful angle. The predator may continue past, following another scent, or stop at the water. Large carnivores cannot afford constant battle. Injury is expensive. A wise predator, if that word can be used cautiously, would choose opportunities rather than glory. The fossil record does not reward animals for dramatic behavior. It rewards animals for surviving long enough to reproduce. Tyrannosaurus abundance in some Hell Creek studies has led researchers to discuss whether it functioned as an opportunistic carnivore rather than a predator with a narrow lion-like role. The comparison to modern hyenas has been used to emphasize flexibility, hunting when possible, scavenging when available, feeding from different sources. This does not make Tyrannosaurus less formidable. It makes it more believable. Top carnivores that survive over evolutionary time are rarely bound by our clean categories. They eat what the ecosystem makes available, and Hell Creek made many kinds of flesh available at different moments. The carcass of a hadrosaur under night air would be a small ecosystem. Bacteria begin first. Insects arrive. Small scavengers take what they can. A crocodiliform may feed if the body lies near water. A tyrannosaur can open the deeper tissues. Bone cracks under pressure. Fluids enter sediment. Footprints surround the body, some from feeders, some from animals drawn only by smell and movement. If a flood comes soon, parts may be buried together. If not, the skeleton may scatter. Years later, no one would know the whole night. They might know only a tooth mark, a broken rib, a concentration of bones. There is a discipline in not knowing. The temptation is to make every fossil a scene, every tooth a kill, every scar a duel. But Hell Creek is more interesting when uncertainty is allowed to remain. A tyrannosaur tooth beside a triceratops bone may represent predation, scavenging, transport, or coincidence depending on context. A bone bed may reflect herding, drought, flooding, or repeated accumulation. A skull ornament may signal display, combat, species recognition, or several functions at once. The ancient night does not become weaker when we admit this. It becomes more real. Nocturnal reconstructions require the same restraint. We can say Hell Creek had nights. We can say animals were active in different parts of the day-night cycle. We can say some dinosaurs may have been cathemeral, moving at intervals across day and night, and that some predators may have used low light. We cannot assign every species a precise schedule with confidence. So the night here is a lens, not a claim that all Hell Creek animals were strictly nocturnal. It is a way of entering the ecosystem when shapes are less certain, and the evidence has to be handled gently. The moon rises over a channel that will not last. Its light catches floating leaves, a turtle shell, the wet side of a log. The bank where the Triceratops stepped begins to slump, and the print loses one edge. A small theropod crosses the same mud quickly, leaving lighter marks. By morning, the two trackways will already be changing. By next season, the channel may cut elsewhere. By the time the sediment becomes rock, the river will be gone. By the time the rock is exposed, the river's shape will be known only through grain size, bedding, and the fossils it spared. Sedimentology gives the landscape back in fragments. Sandstone can mark channels or bars. Mudstone can suggest floodplain deposition. Coal and carbon-rich layers point to wet, plant-heavy environments where organic matter accumulated. Root traces show soils. Paleosols record ancient ground surfaces. Together, these features show that Hell Creek was not a desert badland when the dinosaurs lived there. The badlands are what erosion has made from the rocks. The living Hell Creek was greener, wetter, lower, and closer to water. Its modern exposures are the skeleton of a landscape, not the landscape itself. That transformation from wet floodplain to dry exposure is one of the quiet miracles of deep time. A bone falls into mud. Minerals move through it. sediment hardens around it. Continents shift. Climate changes. The land rises or erodes. Rivers that never knew dinosaurs cut into rock that once was river mud. A fossil appears on a slope under a sky full of birds, and a human recognizes the texture of bone. The recognition lasts seconds. The waiting lasted 66 million years. The fossil hunter kneels. The ancient knight is not visible, but the object in the hill belongs to it. A small piece of rib, a tooth, a scute, a turtle shell fragment, a hadrosaur vertebra, a ceratopsian horn core. Each piece is both evidence and absence. It proves an animal existed, but it also points toward everything not preserved: the skin, the color, the sound, the heat of the body, the fear, the hunger, the weather, the hour. Paleontology begins with what remains and then learns how to respect what does not. Barnum Brown's discoveries in the Hell Creek region helped bring Tyrannosaurus rex into science and public imagination. The first T-Rex skeleton was discovered in Hell Creek, Montana in 1902, and later finds deepened the picture of the animal. But the formation is far larger than one historical discovery. It has continued to produce data through modern fieldwork, museum collections, microsite studies, stratigraphic surveys, and analyses of dinosaur abundance and ecology. The old image of lone fossil hunters pulling giants from hills has been joined by a more detailed science of ecosystems, where even small fragments are cataloged because they help reconstruct the whole. In a museum, a Tyrannosaur skull seems complete because the missing pieces have been restored, or the mount has been arranged to teach the eye. In the field, the past is rarely that generous. Bone may be crushed, scattered, weathered, or incomplete. A tooth may be all that remains of a large predator at a site. A tiny jaw may carry the identity of a mammal more clearly than any postcranial bone. The animal world is reassembled from evidence that survived unevenly. That unevenness is not failure. It is the condition under which the past is available. The darkness of Hell Creek also belongs to plants. Plants do not vanish from the scene because they are not dramatic. They are the basis of most of the visible animal life. Hadrosaurs, ceratopsians, ankylosaurs, pachycephalosaurs, and many small animals depend directly or indirectly on plant productivity. Leaves grow, are eaten, fall, rot, and become soil. Branches break and create shelter. Roots bind banks and then become exposed when channels cut through them. Flowers, seeds, and fruits alter the opportunities available to insects, birds, and mammals. By the latest Cretaceous, this botanical world was already changing toward the one we know. The rise of flowering plants was one of the major ecological transformations of the Cretaceous. Hell Creek records a time after angiosperms had become important components of many terrestrial ecosystems, though conifers, ferns, horsetails, and other older groups still persisted. This mixture made the environment different from earlier Mesozoic landscapes, dominated almost entirely by non-flowering plants. It also meant food resources could vary in new ways: leaves of different textures, seeds and fruits for smaller animals, flowering structures for insects, and plant communities responding quickly to disturbance. The last dinosaur world was not botanically ancient in every sense. It was partly modernizing beneath dinosaur feet. A mammal under a flowering shrub may be feeding in a world that will later favor mammals more strongly. But in this night, it is still small. It has no knowledge of inheritance. It is one nervous body among many. If a small theropod passes too close, it withdraws into cover. If a seed falls, it investigates. If the air changes before rain, it may return to its burrow. The difference between surviving and disappearing can be a decision so small that it leaves no trace at all. The larger dinosaurs are also bound to plants, even the predators. Tyrannosaurus depends on herbivores, and herbivores depend on vegetation. When the impact disrupts photosynthesis, it will strike predators through the bodies of their prey. This is how extinction moves through a food web. It begins at the base and climbs. The largest animals, requiring the most food and the most stable reproductive success are often least able to wait through prolonged collapse. A tyrannosaur can survive a bad week. A lineage cannot survive indefinitely if the young do not grow and the prey base fails. Size brings advantages in stable systems, defense, access to food, dominance, thermal inertia, and fewer predators. But size can become a liability in crisis. Large animals need more resources, mature more slowly, and often require larger territories or more reliable food. Small animals can hide, reduce activity, exploit varied diets, and reproduce more quickly. This does not guarantee survival, but it helps explain why some birds, mammals, reptiles, amphibians, fish, and invertebrates crossed the boundary while non-avian dinosaurs did not. The end was not a moral judgment on size. It was a filtering event that favored certain combinations of traits under catastrophic conditions. Before the filter, a young tyrannosaur drinks from a channel. The water carries bits of plant matter and the taste of upstream mud. Its reflection breaks when insects touch the surface. The animal lifts its head, swallowing, and for a moment the skull is a dark shape against the brighter water. It may live years longer. It may die before adulthood. It may never meet the asteroid's aftermath. In a formation spanning many generations, not every animal is last. Many died long before the end in ordinary ways, and ordinary deaths are the majority of every extinction story. Ordinary deaths create extraordinary records when conditions align. A drought concentrates animals around water. A flood buries them. A channel reworks older bones into a new deposit. A carcass becomes scattered, but some parts settle together. A small pond collects remains from fish, amphibians, turtles, mammals, and dinosaurs over time. In Hell Creek, paleontologists study not only what species are present, but how remains came to be preserved. Taphonomy is the science of that passage from life to fossil, and it prevents us from reading every bone bed as a simple photograph. The ancient night may be inside the deposit, but the deposit has its own history. Some famous end Cretaceous deposits in North Dakota have been interpreted as recording events very close to the impact, including surge-like deposition and impact-related materials. These sites have attracted attention because they seem to preserve extraordinary moments around the boundary. As with all exceptional claims, they are studied, debated, refined, and tested. For Hell Creek, it is enough to say that the region continues to preserve evidence that forces scientists to ask how sudden the end felt on the ground. The last day is not only an astronomical event, it is also a sedimentary question. The impact itself may have begun as light too bright to understand, depending on where one stood on Earth, followed by shaking, atmospheric effects, falling debris, and changes that spread through air and water. In Hell Creek, far from the crater, the animals would not have seen a crater forming. They would have experienced consequences traveling outward. The ground may have trembled, the sky may have changed, material may have fallen into rivers and ponds, the familiar cycle of night and day would have been damaged. After that, the living system entered a crisis for which no local adaptation had been designed. It is easy to imagine the last night before impact as if the world were holding its breath. But that is our knowledge, not theirs. The night before was a night of feeding, resting, mating, calling, hiding, drinking, and avoiding. It may have rained in one part of the basin and stayed clear in another. A tree may have fallen. A nest may have hatched. A tyrannosaur may have failed to catch anything. A mammal may have found enough food to survive another day. Nothing in the mud would have announced that this was the final ordinary darkness. Deep time is full of such unfairness. The Permian world did not know it was before the greatest mass extinction. The Triassic world did not know it was before the rise of dinosaurs. Hell Creek did not know it was before the Cenozoic. Life never stands at the edge of an era with a label in its hand. Eras are named after the fact, when rocks have been measured, fossils compared, boundaries chosen, and dates refined. For living animals, There is only the next movement. One more step into mud. One more breath over water. One more signal in darkness. The Hell Creek Formation is valuable because it sits close to one of those named edges, and because it preserves a diverse terrestrial ecosystem at high resolution compared with many ancient environments. Institutions have collected thousands of specimens from the region, and modern projects have treated the formation not simply as a source of spectacular skeletons, but as a record of changing communities through time. Large dinosaur abundance, microvertebrate assemblages, plant remains, sedimentology, and the position of fossils within the stratigraphic section all matter. The science has moved from asking only what lived here to asking how the whole system was arranged. At night, arrangement becomes sound. Water in the channel, insects in leaves, a low movement from something heavy, the sudden splash of a fish or reptile, a short alarm from a small animal, the slow tearing of plants by a large herbivore, the wind through branches, the footfall of a tyrannosaur far enough away to be felt before it is identified. None of these sounds fossilize, but they are implied by bodies that could make them and environments that would carry them. Silence in a fossil hall is not evidence that the ancient world was silent. Smell would have mattered too. Wet sediment, plant oils, decay, animal breath, dung, stagnant pools, fresh rain on hot leaves. Tyrannosaurs likely relied strongly on smell, but they were not alone. Mammals use scent. Crocodiliforms use chemical and tactile cues. Herbivores detect predators partly through odor. At night, when vision is limited, scent can become a map. A carcass announces itself downwind. A water source carries the smell of many animals. A nesting area may carry the scent of eggs or young. The landscape is readable in ways a human visitor would be poor at understanding. Human imagination tends to privilege sight because our reconstructions are visual: paintings, models, skeletal mounts, animations, but animals inhabit sensory worlds built from their own anatomies. Tyrannosaurus did not experience Hell Creek like a human in darkness. A mammal did not experience it like a Triceratops. A crocodilian at the waterline did not experience it like a bird in cover. Every species had its own version of the same night. Paleontology can sometimes infer sensory capacities from skulls, inner ears, or brain endocasts, but the lived experience remains beyond direct recovery. That distance should make the reconstruction more careful, not less vivid. The inner ear of a dinosaur can tell scientists about balance and sometimes hearing ranges. The shape of the brain case can reveal the relative size of regions associated with smell, vision, or coordination. Tooth wear can reveal how food was processed. Limb proportions can suggest movement. Bone microstructure can suggest growth. None of these data points alone resurrect a night scene, but together they make the scene less arbitrary. They give boundaries to imagination. A good reconstruction does not float above the evidence. It keeps returning to bone, sediment, plant, track, and tooth. Return, then, to a tooth. It lies in mud beside the river, shed or broken from a tyrannosaur jaw. Dinosaurs replaced teeth throughout life, and carnivorous teeth entered sediments often because feeding was rough and teeth were expendable. This tooth is not the whole animal, but it carries a precise geometry: a root end, a crown, serrations, curvature, enamel. Under a microscope, the denticles become a landscape of their own. In a drawer, the tooth becomes data. In the night it came from, it was a working edge. A working edge meets bone when a predator feeds. It meets hide when a bite closes. It meets muscle, tendon, cartilage, and sometimes air if the strike fails. The large teeth of Tyrannosaurus are built to withstand force, and force leaves evidence. Crushed bone, punctures, and healed injuries all remind us that Hell Creek was not a safe place for large herbivores just because they were large. A Triceratops horn could threaten a Tyrannosaur. A Tyrannosaur bite could ruin a Triceratops. Neither fact turns the ecosystem into constant battle. It turns it into risk distributed across time. The famous confrontation between Tyrannosaurus and Triceratops has some basis in overlapping fossils, bite marks, and ecology, but it has also been magnified by culture into a permanent duel. Most of the time, those animals were not fighting. They were feeding, moving, resting, reproducing, and avoiding unnecessary injury. A predator that attacks every dangerous animal it sees dies young. A herbivore that fights when flight or posture would work wastes energy. The night between them would often be a negotiation of distance. The Tyrannosaur tests the situation. The Triceratops turns. The cost rises. The predator moves on. Sometimes moving on is the most realistic ending to a scene. The Tyrannosaur follows the bank toward another scent. The Triceratops returns to feeding after a long stillness. Smaller animals resume movement gradually, not all at once. The river continues. The stars change position. A footprint fills. Nothing dramatic happens, and for that reason the animals live another night. The fossil record overrepresents death, because death is what leaves bodies behind. Life, most of the time, is the avoided event. That avoided event repeated through millions of lives. Every fossil skeleton represents an animal that survived countless previous hazards before the final one. The mounted Triceratops in a museum did not simply die. It first lived through seasons of growth, feeding, danger, healing, and change. A tyrannosaur tooth in a drawer was once replaced by another tooth in a living jaw. A mammal jaw fragment belonged to a creature whose heart beat in a world of giants. The last days of the dinosaur world were made of lives that had already been long by their own scale. The length of the Hell Creek interval varies depending on locality and definition, but the formation represents roughly the final couple of million years before the KPG boundary in many studied areas. That is a short time geologically and an immense time biologically. 2 million years is enough for rivers to migrate endlessly, for populations to fluctuate, for lineages to shift, and for countless generations of small animals to pass. When we compress it into a single cinematic night, we should remember the compression. The image is a doorway, not the whole archive. The archive includes pollen grains too small to see without magnification. Pollen can survive where leaves do not, and it helps reconstruct plant communities before and after the boundary. At the extinction, plant life was disrupted. Fern spores in some boundary sections suggest early recovery by pioneer plants after devastation, a pattern sometimes called a fern spike in broader KPG studies. In the living Hell Creek night, none of that is visible. Ferns are simply fronds near the wet ground. Flowering plants are simply leaves and stems. Pollen drifts without anyone naming it evidence. Evidence often begins as something ordinary. A leaf falls into still water and is buried in fine sediment. A fish dies in a pond. A turtle's shell is covered by mud. A mammal tooth survives digestion or transport. A dinosaur bone is trampled, broken, and later mineralized. A wildfire leaves charcoal. A flood carries a mixture of remains into a low area. Later, scientists separate these events through stratigraphy, chemistry, anatomy, and comparison. The ancient night is not preserved whole, but its ordinary materials are preserved often enough to build a disciplined reconstruction. What would the air feel like? Likely warmer and more humid than the modern Badlands, with seasonal variation and local differences across the floodplain. Near water, the night air would hold moisture. Away from channels, it might cool more quickly over open ground. Insects would gather where conditions suited them. Decomposition would be faster in warm, wet settings. Plants would release smells after rain. Mud would cling to feet. Large animals would carry heat long after sunset. The environment was not a neutral backdrop. It pressed against every body. A hadrosaur resting on folded limbs, if it rested that way in a sheltered place, would still be listening. Large herbivores cannot leave the world completely. Their sleep, like the sleep of many prey animals, may have been broken attentive, distributed among members of a group if group behavior was present. One animal lifts its head. Another shifts. A juvenile nudges closer to a larger body. A branch cracks in the dark, and the question passes through the group before any animal moves. The night is made of these small decisions. Herding in hadrosaurs and other dinosaurs is supported in some formations by bone beds, trackways, nesting grounds, and repeated associations, but each case must be evaluated separately. For Edmontosaurus and related animals, group living is plausible and often inferred, though the exact structure of groups in Hell Creek cannot be observed directly. The value of cautious language is not to drain the scene of life, it is to keep the scene connected to what evidence can support. A herd is not a certainty in every paragraph. It is a possibility used where it fits the broader biology. If a large group moved at night, the floodplain would feel its passage. The ground would churn. Plants would bend. The smell of many bodies would collect near water. Young animals would step into older tracks. The riverbank would hold overlapping impressions until water or drying broke them down. Such movement could shape the physical environment. Large herbivores are landscape engineers. They open paths, spread seeds, break branches, compact soil, disturb banks, and turn vegetation into dung. Even without intention, they alter the world their own young inherit. A predator follows those alterations. It does not need to understand ecology to use a path. It follows scent along a route that large bodies have kept open. It moves where the ground is firm enough. It pauses where a bank narrows. It watches the edges of a group or listens for an animal separated by injury, age, or confusion. A successful hunt may be brief after hours of positioning. A failed hunt may leave no trace at all. Fossils preserve the failures of bodies, not the failures of attempts. This is one reason predator behavior is difficult to reconstruct. A kill that leaves tooth marks on bone may be recognized. A chase that fails disappears completely. A threat display leaves nothing. Avoidance leaves nothing. The non-events that structure animal lives are almost invisible in deep time. Yet they must have happened constantly. Most nights in Hell Creek did not end with a tyrannosaur feeding. Most approaches failed, were abandoned, or never became approaches. Ecosystems require energy efficiency as much as violence. Predators spend much of life conserving energy, not spending it for spectacle. The moon climbs higher. On a sandbar, the surface is cooler now. Small tracks mark the damp edge, perhaps a lizard, perhaps a mammal, perhaps a juvenile dinosaur depending on the shape. A beetle moves through the track wall as if through a valley. The scale changes again. What is a footprint to one animal is terrain to another. This is how Hell Creek should be held in the mind, not as one scale, but as many nested scales, each with its own dangers, shelters, and meanings. The smallest fossils often need the greatest attention. A screen-washed sample can reveal teeth from fish, mammals, salamanders, lizards, crocodilians, and dinosaurs that would otherwise remain in the hill. These fossils help reconstruct environments with more precision than large skeletons alone. If a deposit contains aquatic taxa, it tells us water was nearby or that transport occurred. If mammal teeth are abundant, they tell us about small-bodied diversity. If plant fragments and pollen are preserved, they help place the animals within a vegetation mosaic. The night becomes fuller as the fragments become smaller. A frog call does not fossilize, but an amphibian vertebra can. A wing beat does not fossilize, but a bird bone might. A smell does not fossilize, but a pollen grain can imply the plant that produced it. A moment of fear does not fossilize, but a healed bite shows that an animal once escaped. The record is indirect, and that is why it is powerful. It asks for a mind willing to move from object to life without pretending the object contains everything. Hell Creek research has also been shaped by the need to place fossils precisely within the formation. A specimen's position matters. A dinosaur found low in the formation may represent an earlier part of the interval than one found near the boundary. Without stratigraphic control, fossils become a list. With stratigraphic control, they become a sequence. Scientists can then ask whether communities changed through time, whether certain taxa became more or less common, whether environmental conditions shifted, and how close non-avian dinosaurs occur to the boundary. The last days become a measurable problem rather than only a phrase. The phrase 3-meter gap once referred to the apparent absence of dinosaur fossils in the very topmost meters below the KPG boundary in some places, raising questions about whether dinosaurs had already declined before the impact. Later finds and debates complicated that picture, with some evidence placing dinosaurs closer to the boundary. The broader issue remains difficult because absence in rock can mean true absence, poor preservation, limited exposure, or limited sampling. A missing fossil is not automatically a missing animal. The end of Hell Creek life has to be read through both presence and silence. Silence is not nothing in science, but it must be handled carefully. If many well-sampled sections consistently lack a fossil group, that pattern may mean something. If sampling is uneven or preservation poor, it may not. This matters because the story of extinction has often been pulled between sudden catastrophe and gradual decline. The impact is real and central, but ecosystems before it were also changing in a dynamic world of sea level shifts, climate variation, volcanism elsewhere, and regional ecological patterns. The strongest account does not need to make one cause erase all complexity. It can hold complexity and still recognize catastrophe. The animals in the last night do not hold complexity. They hold habits. A Triceratops follows a familiar path. A mammal searches a familiar log. A crocodilian waits at a familiar bend. A tyrannosaur tests the wind because wind carries information. The river lowers because rain has not fallen upstream for days, or it rises because rain has fallen hard beyond the horizon. The living world is local. Even a global extinction arrives through local experiences. A darkened sky over this river, failed plants in this floodplain, hunger in this body. That is where the title becomes most meaningful. Hell Creek at night is not only a mood, it is a way of placing the final dinosaur world back into hours, weather, and ground. The last days were not an abstract decline curve. They were physical. Mud under feet, water in channels, leaves between teeth, bone inside skin, eggs under sediment or vegetation, insects in humid air, a tooth lost beside a carcass, a horn lowered in darkness, a small mammal alive under roots while giant animals moved above it. The non-avian dinosaurs of Hell Creek were part of the Lanchian North American land vertebrate age, a regional slice of the latest Cretaceous. Regional terms like this help paleontologists compare faunas across formations and locations. Hell Creek, Lance, Frenchman, Scholard, and other roughly equivalent deposits preserve related but locally distinct communities near the end of the Cretaceous in North America. Comparing them reveals both shared patterns and regional differences. No formation is the whole world. Hell Creek is a crucial window, not the entire house. Through that window, we see a continent different from ours. The Rocky Mountain region was not the same. The seaway that once split North America was withdrawing. Drainages, coastlines, and lowlands were arranged differently. The modern political map has no meaning. Montana is not Montana. North Dakota is not North Dakota. The animals do not cross state lines. They move through basins, rivers, forests, marshes, and open patches under a climate that would make the modern northern plains feel like a poor guide. The climate of Hell Creek is generally reconstructed as warm temperate to subtropical, with wet conditions and seasonal patterns. Exact estimates vary by method and locality, using plant fossils, isotopes, sedimentology, and comparison with modern environments. The key point for the narration is not a single number. It is the environmental feel, a lowland coastal plain with abundant water in many areas, forested floodplains, swampy zones, rivers and lakes, and periodic disturbance. The animals lived in a humid, productive landscape, not on the dry, eroded slopes where their fossils are now exposed. In the ancient wet season, night rain may fall warm enough that it does not chill the body quickly. Leaves shake under heavy drops. The surface of a pond becomes a field of rings. A hadrosaur track softens at the edges. A small mammal retreats deeper beneath roots. A tyrannosaur lowers its head against rain, not in drama, just because rain interrupts scent and sound. Water flows down the bank and begins making the next layer. Every drop participates in geology if given enough time. In the dry season, the same place contracts. Pools shrink. Mud cracks. Fish concentrate in deeper channels. Herbivores travel farther between feeding areas and water. Predators learn where animals must come. Carcasses last differently under drier conditions. Bones weather, split, and scatter before burial. A night in the dry season would carry more dust, more exposed bank, perhaps more tension around water. The fossil record of a floodplain is partly the record of these oscillations: too much water, not enough water, and the animals living between them. Waterholes are dangerous in any large animal ecosystem. They attract prey and predators, the healthy and the weakened, the young and the old. A Triceratops must drink. An Edmontosaurus must drink. A Tyrannosaur can wait where drinking narrows options. Crocodiliforms use the edge from below. Small animals come when larger ones have moved away, or when cover seems safe. The night around water is layered with attention. No animal sees the whole system, but every animal is affected by it. Attention does not mean human-like thought. It means sensory processing tied to survival. A herbivore that reacts to movement survives more often. A predator that judges distance and risk feeds more successfully. A mammal that distinguishes harmless noise from danger wastes less energy. Natural selection builds these capacities without needing narrative. When we describe ancient animals as watching, listening, or choosing, we are translating biological processes into language. The translation is imperfect, but the underlying behavior is real. Animals are not machines. They respond to the world. A response can be very small. One step backward. A head raised. A pause in chewing. A shift downwind. A retreat into water. A deeper stillness under a log. In a fossil, these responses vanish unless they lead to death, tracks, injuries, or unusual preservation. The night is therefore mostly gone. What remains is enough to know it happened, not enough to own it completely. This partialness is not a weakness of the story. It is the texture of deep time. We do not stand in Hell Creek as witnesses. We stand at its eroded edge, holding pieces. We build from a horn core, a tooth row, a turtle shell, a pollen grain, a sandstone lens, a clay seam, a geochemical spike. The living world is approached through evidence that has crossed an impossible distance. When the reconstruction becomes cinematic, it should do so in service of those pieces, not in place of them. So the camera, if there were one, would not rush. It would stay low at the bank. It would watch the water move around a footprint. It would follow a beetle over the edge of the print. It would lift slowly to show the dark body of a hadrosaur beyond the reeds. It would not need music to tell you the animal is large. The ground already knows. The plants already show it. The mud is enough. Edmontosaurus was a highly successful hadrosaur, and its remains from latest Cretaceous deposits show a large herbivore capable of thriving in these environments. Some exceptional hadrosaur fossils elsewhere preserve skin impressions, giving a sense of scale patterns and body covering, though not every Hell Creek individual preserves such details. The broader point is that hadrosaurs were not simple duck-billed background animals. They were complex, efficient herbivores, with sophisticated chewing systems and bodies suited to sustained feeding and movement across floodplains. In Hell Creek, they would have been major converters of plant matter into animal biomass. Their social behavior, migration patterns, and daily schedules remain topics for inference. A large hadrosaur population may have moved according to food and water availability, but the details are not the same as tracking a modern herd. We can use modern animals for analogy, but analogies are tools, not answers. Bison, elephants, deer, crocodiles, birds, and mammals can help us think about behavior, but no living animal is Edmontosaurus. The Cretaceous system had its own combinations. Good reconstruction borrows carefully and then returns to the fossils. A hadrosaur lowers its head into the water. Its nostrils are not exactly where a human first expects them to be on the skull, because the skull is long and specialized. The beak touches the surface. Water breaks. For a moment, the reflection of the head doubles and disappears. Around the animal's legs, mud squeezes upward. A leech-like invertebrate, a small fish, a turtle, a root, each exists at a different scale of the same movement. The animal drinks, and the landscape adjusts. If a tyrannosaur attacks, the scene becomes violent quickly, but not cleanly. Mud gives way. Bodies turn. A hadrosaur tries to accelerate on bad ground. The predator aims for flesh, not drama. Teeth meet the side, thigh, tail base, or whatever the angle allows. The outcome is uncertain. Large prey can escape injured. Predators can fail and still survive. A healed wound in bone can be more revealing than a perfect kill because it proves an encounter was not fatal. It shows life after violence. Healed injuries in fossils are valuable because they preserve time. A broken rib that healed means the animal lived after trauma. A bite wound with remodeling means infection was resisted or endured. A fused vertebra means stress or injury became part of the skeleton. These pathologies make ancient animals individual in a way measurements alone cannot. They remind us that a species is not a uniform diagram. It is a population of bodies with histories, some short, some long, some marked by damage. Night hides those histories on the outside. A scar may be under feathers, scales, or skin. A limp may be noticeable only when the animal moves. An old tyrannosaur may choose easier food. An aging Triceratops may stay closer to water. A juvenile hadrosaur may carry a healed bite that changed how it moves. The fossil record gives us glimpses of injury, but in life those injuries altered behavior in practical ways. The ancient world was full of animals compensating. What colors moved through Hell Creek at night? Color is rarely preserved directly for these animals, and in darkness, even bright patterns fade. But display structures suggest that visual signaling mattered in at least some dinosaurs. Ceratopsian frills, pachycephalosaur domes, feathers in small theropods, and skin patterns in hadrosaurs could all have played roles in recognition or display. At night, color would yield to outline and movement unless moonlight or twilight allowed more. The frill becomes a silhouette. Feathers become a texture. A body pattern becomes less important than scent, posture, and sound. We should not overfill the darkness with calls. Dinosaurs likely vocalized in some ways, and living birds and crocodilians both provide clues that archosaurs can produce a range of sounds. But the exact voices of Tyrannosaurus, Triceratops, or Edmontosaurus are unknown. They may have used low-frequency sounds, closed-mouth vocalizations, hisses, bellows, or other signals depending on anatomy and context, but specific claims are speculative. A restrained reconstruction can allow sound without pretending to record it. The night probably was not silent. It also was not a monster soundtrack. A low sound moves over water. Perhaps it is a large animal. Perhaps it is wind through a hollow log. The animals that live here do not need certainty before reacting. They need useful probability. One head lifts, then another. A mammal freezes. The crocodilian does not move. The sound fades. The night resumes, but not exactly as before. Attention has shifted. For a few minutes, feeding slows along the bank. This kind of moment is nearly impossible to fossilize, yet it may have been common. Behavior structures ecosystems as much as anatomy does. Where animals choose to feed, when they approach water, how they respond to predators, where they nest, how they move through vegetation, and how they use day and night all affect survival and preservation. Fossils capture the consequences only indirectly. A concentration of bones near a channel may suggest repeated use of the area. A trackway may suggest movement direction. A nesting horizon elsewhere may reveal reproductive behavior. Hell Creek offers many clues, but not a complete behavioral archive. The incomplete archive is still vast. More than a century of work has turned Hell Creek into one of the most intensively studied windows on the end of the Cretaceous. Its fossils have shaped how the world imagines the final dinosaurs. Its sediments have helped frame debates about extinction tempo. Its microfossils have expanded the cast beyond giants. Its boundary layers connect a riverine coastal plain in North America to a crater in Mexico and to a global layer of chemical evidence. Few landscapes have carried so much of Earth history in such eroded hills. Yet, in the living night, the hills were not eroded. They were lowlands. A channel curves under trees. A bank collapses with a wet sound. A hadrosaur startles, then settles. A Triceratops steps over a fallen branch, 1 foot sinking deeper than expected. The animal pulls free, leaving a distorted print. The print may not last until sunrise. Most traces do not. The past is mostly unpreserved, and still, enough survives to bring us here. The end, when it comes, does not ask which animals were iconic. It does not spare a lineage because its skull was magnificent. It does not remove a species because it was primitive. It is a physical event with biological consequences. The impact throws material into the atmosphere, changes light and temperature, disrupts plant growth, and cascades through food webs. Non-avian dinosaurs, pterosaurs, ammonites, many marine reptiles, and many other groups vanish. Others survive in reduced, damaged worlds. Survival is uneven, and unevenness becomes the new history. Mass extinction is not simply death on a large scale, it is selective restructuring. Some groups lose all members. Some lose most. Some pass through with losses and later diversify. Crocodiliforms survive. Turtles survive. Birds survive. Mammals survive. Amphibians and fish survive in varying patterns. Plants suffer and recover. The aftermath is not immediate paradise for survivors. It is a world of scarcity and opportunity mixed together, where vacant niches exist because the systems that once filled them have collapsed. The Paleogene begins in recovery, not triumph. The first Paleogene nights above Hell Creek would have been poorer in large footsteps. No Triceratops pushing through wet shrubs, no Tyrannosaur testing the wind along the channel, no Edmontosaurus herd shifting in the dark. The river still moves, frogs still call if they survived locally. Turtles still enter water. Mammals search through debris. Birds settle into cover. But the ground has lost a weight it carried for more than 100 million years in different forms. Absence becomes part of the soundscape. Absence can be difficult to fossilize too. It appears as no bones where bones once were, as changed pollen assemblages, as lower diversity, as communities reorganizing in the layers above. The Fort Union world is not empty, but it is not Hell Creek. The boundary separates not only taxa, but ecological relationships, predators from prey, herbivores from plants they shaped, scavengers from carcasses they depended on, small animals from the shadows cast by giants. When the giants disappear, the shadows disappear too, and the small animals face a different light. For mammals, that different light eventually becomes expansion. Not immediately into elephants, whales, horses, bats, primates, and humans. Those come later, through long radiations and many experiments, but the possibility opens because the old large-bodied dinosaur roles are vacant. The small nocturnal or crepuscular habits that helped Mesozoic mammals survive become foundations for new forms. Teeth diversify. Bodies grow. Ecologies widen. The mammals do not win because they were secretly superior all along. They survive the filter, and then evolve into the open spaces it leaves. Birds follow another path. They are dinosaurs that cross the boundary, but not all birds survive. The lineages that do survive give rise eventually to the modern bird radiation, though the timing and details are complex. Their survival likely involved small size, flight, flexible diets in some lineages, and the ability to find refuge in a disrupted world. When a bird calls outside a modern window, it is connected to the dinosaur age more directly than any museum mount. It is not the echo of Hell Creek exactly, but it is a living continuation of the broader dinosaur story. A modern crow at dusk, stepping along a riverbank, has more in common with the small surviving dinosaurs than with Tyrannosaurus in scale, but the connection is still real. Feathers, wishbone, air sacs, egg-laying, and other features belong to a deep history of theropod evolution. The dinosaur world did not end as completely as the old phrase suggests. It narrowed, passed through catastrophe, and emerged transformed. Hell Creek at night, therefore, holds both ending and continuity. The giant forms are near their end. The smaller branch is already waiting in plain sight. The river does not know any of this. It carries mud. It cuts banks. It deposits sand. It moves leaves, fish, carcasses, and minerals. It records without intention. A tyrannosaur tooth falls near it. A turtle shell settles in it. A log jams against a bend and changes the current. The river is one of the main authors of the formation, though it never means to write. Its sentences are channels. Its punctuation is flood. By dawn, the night animals reduce their movement. Some retreat to cover. Others continue because large herbivores may feed across many hours. The first light spreads over the floodplain slowly, through mist and wet leaves. Tracks made in darkness become visible. A hadrosaur path crosses a sandbar. A Triceratops print has collapsed at the heel. Small marks stitch the mud between larger ones. The riverbank looks used. Because it is. The world has survived another night. In most generations, another night would follow. Then, another. The animals would not live in constant ending. They would live in repetition broken by storms, droughts, births, injuries, migrations, and deaths. That repetition is what extinction interrupts. It is not only the removal of species names from a list, it is the stopping of habits. No more tyrannosaur paths along certain banks. No more ceratopsian feeding pressure on certain plants. No more hadrosaur herds opening routes through vegetation. No more ankylosaur armor moving under Cretaceous trees. Ecosystem function changes when major animals disappear. Large herbivores affect plant communities. Large predators affect prey behavior and carcass distribution. Burrowing animals affect soil. Aquatic reptiles affect river food webs. The end Cretaceous extinction reorganized these roles globally, though local patterns varied. In Hell Creek, the disappearance of non-avian dinosaurs would have altered vegetation dynamics, nutrient cycling, scavenging, predator-prey relationships, and the physical use of the landscape. The rocks above the boundary record recovery, but recovery is not restoration. It is a new assembly. That new assembly eventually leads to us, but the story should not make humans the purpose of the past. Hell Creek did not exist to become our prehistory. It existed because Earth at that moment produced a warm coastal plain filled with rivers, plants, and animals. The fact that we can study it is remarkable, but it does not make us the destination. We are late readers of a book not written for us. The pages that survive are torn, mineralized, and scattered across badlands. When a paleontologist brushes sediment from a bone, the gesture is careful because the object is both hard and fragile. It has survived deep time and can still be damaged by a careless hand. The same is true of the story. It has survived in pieces, and it can be damaged by certainty, where certainty is not earned. The night we imagine must be brushed into view, not blasted open. A little mud remains on everything. This is why the best Hell Creek scene is not one where every animal appears on command. It is one where the ecosystem breathes around what evidence permits. There may be a Tyrannosaur, or only its tooth. There may be a Triceratops, or only a track and a horn core weathering from a hill millions of years later. There may be mammals under leaves, though we see them mostly through jaws and teeth. There may be birds, though their bones are rare. The scene is strongest when it knows which parts are visible and which are inferred. The inferred parts are still intimate. Warm mud around toes. A pulse under skin. A small animal's whiskers against a root. Rain on a frill. Water dripping from a tyrannosaur's jaw after it drinks. Leaves crushed under an ankylosaur's weight. A turtle sliding from a bank into black water. A bird shifting its feet on a branch. None of these require exaggeration. They are enough because they make the ancient world physical again. Physicality is also what connects Hell Creek to the modern world. The formation is exposed because erosion removes overlying material. Fossils enter collections because people walk slopes, notice textures, map localities, record positions, jacket bones, prepare them, compare them, and publish results. Every specimen has a second history after discovery: field notes, plaster, transport, preparation, catalog numbers, storage, study, display, and sometimes reinterpretation. The dinosaur's first life ended 66 million years ago. Its scientific life begins when someone recognizes it. Scientific lives can change. A specimen named one way may later be revised. A bone thought to belong to one animal may be reassigned. A famous interpretation may be challenged by new data. Hell Creek has seen debates over tyrannosaur ecology, ceratopsian taxonomy, pachycephalosaur growth, dinosaur diversity near the boundary, and the tempo of extinction. This is not weakness in the science, it is the science working. A fossil does not speak once, it is questioned again as methods improve. The ancient night remains behind those questions. Patient because it has no need to answer quickly, it has already happened. We are the ones who hurry. We want to know whether Tyrannosaurus hunted at night, whether Triceratops moved in groups, whether the dinosaurs were thriving until the last moment, whether one deposit preserves the very day of impact. The rocks answer slowly, sometimes with fragments, sometimes with contradictions. They ask us to be content with progress rather than possession. Possession would be impossible anyway. Even a time machine would not give a complete Hell Creek. Stand in one place for one night and you would miss the formation. You would see one bend, one storm, one animal path, one set of sounds. The next valley might differ. The next season would differ. A site 200,000 years older would differ. Deep time is not a single panorama. It is a stack of lived moments too numerous to imagine. The formation preserves a selection, and the mind turns selection into story. So the story returns to the bank where it began. The print has changed. Its edges are softer. A small insect stands on the water gathered in the deepest part. The river has taken one side of the track and left the other. A leaf drifts into it, turns once, and settles. The dinosaur that made the print is gone into the trees or already far down the floodplain. It may live for years. It may die before the season turns. Its track may vanish before noon. But for this moment, the mud has shape. Millions of years later, shape is what we are given. The curve of a horn, the serration of a tooth, the socket of an eye, the dome of a skull, the armor of a back, the cross-section of a river channel in sandstone, the dark seam near the boundary. These shapes are modest compared with life, but they are not small. They are the remaining edges of a world that once had nights, and the edges are enough to begin. The age of non-avian dinosaurs ended at the KPG boundary, but the study of that ending is still active. Dates are refined. Models of impact effects are tested. Deccan volcanism is studied for its role in environmental stress. Local extinction patterns are reassessed. New fossils are found. Old collections are revisited. Hell Creek remains central because it preserves terrestrial life close to the boundary in a region with a long history of collection and research. The last days are not a closed chapter. They are a scientific frontier built from old rocks. In that frontier, certainty comes in layers. We can be certain Tyrannosaurus lived here. We can be certain Triceratops and Edmontosaurus were major dinosaurs of this world. We can be certain the environment included rivers, floodplains, lakes, and forested soils. We can be certain the KPG boundary marks a profound extinction and that the Chicxulub impact was a central cause. We must be less certain about the exact behavior of a given animal on a given night. The honest reconstruction keeps those layers separate. Honesty does not make the night less cinematic, it makes it quieter. The river does not need to glow with prophecy. The Tyrannosaur does not need to roar at the asteroid. The Triceratops does not need to stand as the last of its kind under a burning sky. A more truthful ending is smaller and larger at once, animals living normally until normal life is no longer possible, a world full of ordinary acts interrupted by an extraordinary event. After the impact, the ordinary acts fail. Feeding becomes harder. Warmth becomes less reliable. Plant growth slows or collapses in many systems. Food chains shorten. Carcasses feed scavengers for a time, then scarcity deepens. Large herbivores cannot find enough plant matter. Large predators cannot find enough prey. Nests fail. Juveniles do not recruit into adult populations. The ecosystem loses not only individuals but continuity. Extinction is continuity breaking. Yet continuity survives elsewhere in altered form. A small bird finds shelter. A mammal remains underground through the worst hours, then emerges to search among debris. A turtle waits in water. Seeds endure. Ferns colonize open ground. Life narrows, then widens again. The story after Hell Creek is not comfort in the simple sense. It is evidence that life can recover after devastation, but never by reversing time. Recovery makes something new from what remains. For the Mesozoic world, what remained did not include the great non-avian dinosaurs. That absence allowed mammals and birds to diversify in ways that would have been unlikely under the old ecological order. The Cenozoic did not begin cleanly, it began with survivors and ruins. Over millions of years, forests changed, mammals grew larger, birds diversified, and eventually grasslands appeared. Whales returned to the sea, bats took flight, primates evolved, and humans arrived very late. Hell Creek is not the start of that whole story, but it is one of the doors it passes through. A door in rock can be surprisingly thin. Below, a world of Tyrannosaurus and Triceratops. Above, a world without them. The boundary is not always exposed clearly, and local geology complicates the picture. But conceptually, it is one of the sharpest changes in the history of terrestrial life. When a geologist points to a boundary layer, they are pointing to a time surface. When a paleontologist finds dinosaur bone below it, the distance between bone and boundary becomes a question. How close? How many generations? How much life remained? Those questions matter because they shape whether the end is imagined as a long fading or a sudden severing. The best current picture allows both background complexity and abrupt catastrophe. Some environments were changing. Some groups may have been under stress. Volcanism may have contributed environmental pressure, but the impact delivered a global shock that the non-avian dinosaurs did not survive. Hell Creek, with its rich latest Cretaceous record, places real animals in the path of that conclusion. It prevents extinction from becoming only a diagram. The diagram becomes a riverbank again. A body stands in the dark, breathing. Another body listens. Water moves. Leaves drip. Somewhere, very far away in space and time, an asteroid is already on an orbit that will intersect Earth. No animal knows this. No plant changes because of it. No river slows. The night remains itself until it cannot. This is the scale that makes Hell Creek difficult. The local and the cosmic meet without warning. A mammal under a root and a crater in Mexico belong to the same story. A tyrannosaur tooth in Montana and iridium and boundary clay belong to the same story. A bird outside a modern window belongs to the same story. The connections are real, but they are not visible from inside any single moment. They are visible only after time has done its work and science has learned how to read the remains. To read those remains is to look at extinction without reducing it to spectacle. The asteroid was spectacular beyond human experience, but the extinction itself unfolded through living systems: light lost, plants stressed, animals hungry, reproduction broken, populations shrinking, lineages ending. The last days of the dinosaur world were not only fire in the sky, they were also the quiet failure of familiar patterns. Paths no longer used, nests no longer returning young, riverbanks no longer pressed by the same feet. Non-avian dinosaur extinction was complete, but many dinosaur relatives and contemporaries survived. Birds crossed the boundary. Crocodilians and their relatives crossed. Turtles crossed. Mammals crossed. Some plants crossed. Many insects crossed. This uneven survival is why the modern world carries both loss and inheritance. A crocodile at a riverbank is not a living Hell Creek animal, but it can help us imagine the persistence of certain aquatic strategies. A bird is more direct, a living dinosaur, changed by time, but still part of the same great branch. Another way to enter Hell Creek at night is through the hour just after sunset, when the day's activity has not ended cleanly and the true nocturnal rhythm has not fully begun. This in-between time may have been important for many animals. Temperatures ease. The glare leaves open ground. Insects change their movement. Water draws animals that avoided exposed banks during the hotter hours. A large herbivore can feed longer without the same heat stress. A predator can move under softer light. The fossil record does not mark twilight, but biology makes twilight plausible as a busy interval. Many modern animals favor edges of the day, and a late Cretaceous floodplain would have offered similar reasons to use them. The first shadows lengthen across plants that are themselves part of a changing Mesozoic story. A flowering shrub bends where a hadrosaur has fed. Ferns grow in damp zones where older plant lineages still do well. Conifers hold the higher canopy in places. Leaves fall into water and begin the slow path towards sediment. A beetle works under bark. A small animal pulls at a seed. The plant world has no awareness of being before or after anything, but it is helping to build the conditions for the next era. Angiosperms are not yet the whole world, but they are no longer an experiment hidden at the margins. The insects of the evening would have followed plant life closely. Some fed on leaves, some on decaying material, some on wood, some on other insects. Flowering plants created new relationships, though the exact pollinator communities of Hell Creek cannot be reconstructed in complete detail. Mosquito-like flies, beetles, midges, and other small insects would have filled the air where moisture and vegetation allowed. Their activity matters because insects connect plants to vertebrates. They feed birds, mammals, lizards, amphibians, small dinosaurs, and fish. A swarm above still water may look like atmosphere, but it is food suspended in air. A small bird, or bird-like dinosaur at dusk, would read that air differently from a mammal under roots. It might pursue insects near the bank, then vanish into cover when larger movement begins. A small theropod might work the same edge from the ground. Competition between early birds and small non-avian theropods is difficult to observe directly, but their overlapping sizes and diets make the question interesting. The end of the Cretaceous did not simply remove large dinosaurs and leave small worlds untouched. It also filtered small, delicate, active lineages, some of which survived and some of which did not. Hell Creek birds are known from fragmentary remains, and many of the famous details of early bird evolution come from other deposits. Still, The presence of avian fossils near the end of the Cretaceous in North America places birds inside this final ecosystem. Their rarity in the record reflects preservation as much as abundance. Small, hollow bones can be destroyed easily, transported away, or overlooked in coarse collecting. When they are found, they remind us that the boundary did not divide dinosaurs from non-dinosaurs in a simple way. It divided branches of Dinosauria from one another. A branch dips under a small body's weight, then rises again when it leaves. The movement would not disturb a Triceratops. It might matter greatly to an insect. In a world of giant herbivores and giant predators, the small aerial life is easy to miss. But night is often kinder to small movement than daylight. It hides scale. A flutter under leaves, a mammal's step on dry litter, the click of an insect against bark, all belong to a different rhythm from the heavy bodies near the channel. Near the water, however, heavy bodies dominate the surface. A large herbivore crossing a shallow channel can change the bank for every animal after it. The foot enters, mud rises around it, water clouds, and the current carries the disturbed sediment downstream. Small fish move away from the pressure wave. A turtle withdraws its head. A crocodiliform may remain still because stillness is part of its hunting. When the foot lifts, the track begins filling immediately. The act of walking is also an act of writing and erasing. Track preservation depends on the timing between impression, drying, filling, and later burial. Too much water and the print collapses. Too little sediment and it erodes. A thin layer of mud receiving the foot, followed by sand or silt that fills the shape without destroying it, can make a track fossil possible. That sequence is specific. And that is why footprints are both common in some settings and absent in others where animals surely walked. Every trackway is a lucky collaboration between behavior and sediment. Every missing trackway is not proof that animals were absent. The same logic applies to nests and eggs. Dinosaur reproduction was widespread and essential, but nesting evidence preserves only under certain conditions. Some late Cretaceous deposits elsewhere reveal nesting colonies or eggshell horizons. Hell Creek provides fragments and clues, but not a complete nursery map. Even without perfect evidence, the ecosystem required young animals at every scale. Hatchlings and juveniles are implied by adults the way seeds are implied by forests. At night, the vulnerable young are among the most important hidden presences in the landscape. A juvenile Edmontosaurus does not need to be described with certainty to be understood as vulnerable. Its legs are smaller, its experience shorter, its body easier to take. It may stay close to larger animals if group structure allows it. It may feed in safer spaces, or it may be forced toward risk by hunger and water. A young Tyrannosaur has a different problem. It must eat without yet possessing the full power of an adult. Juveniles of predator and prey both live in the same difficult school, where mistakes can be final. Ontogeny can create ecological diversity inside a single species. If young tyrannosaurs hunted different prey from adults, then Tyrannosaurus as a species occupied more than one predatory role across its life history. If young ceratopsians fed differently from adults, they may have used vegetation at different heights or textures. These possibilities are not unusual in living animals. Crocodilians, birds, mammals, and reptiles often change diets or habitats as they grow. In Hell Creek, such changes would help explain how large populations could divide resources without requiring every niche to belong to a separate species. A living ecosystem is therefore wider than its species list. It includes babies, juveniles, subadults, prime adults, old individuals, injured individuals, breeding animals, wandering animals, and animals displaced by flood or drought. A formation's faunal list says Tyrannosaurus, Triceratops, Edmontosaurus, Ankylosaurus, and others. The living night says a limping adult, a half-grown predator, a young herbivore hidden near reeds, a turtle missing part of its shell, a mammal with worn teeth. The species name is the doorway. The population is the room. Worn teeth are another kind of clock. Herbivores wear teeth through plant processing. Carnivores damage teeth during feeding. Replacement teeth move into place. A jaw becomes a record of use. In a hadrosaur, the dental battery is almost industrial in its efficiency, but it is still biological tissue under constant wear. In a ceratopsin, the slicing surfaces are renewed as old teeth are lost. In a tyrannosaur, each tooth is a temporary tool. The mouth is not a static display, it is a changing machine shaped by meals. Diet is reconstructed from teeth, jaws, wear, gut contents when preserved. Coprolites, isotopes in some cases, and ecological context. For Hell Creek, broad feeding categories are clear enough. Large herbivores processed plants, tyrannosaurs and smaller theropods ate meat or mixed resources depending on lineage. Mammals used varied small-scale diets. Crocodiliforms and champsosaurs hunted aquatic or semi-aquatic prey. Fish and amphibians formed their own food webs. Exact menus vary and are often uncertain. The important point is that energy moved through many channels, not one simple chain. Imagine following a single leaf. It grows on a flowering plant near a levee. A hadrosaur crops the branch but misses that leaf. Wind tears it loose after dark. It falls into water, softens, becomes food for microbes and small invertebrates, which feed fish or amphibians, which may feed a crocodilian or a bird, which may eventually become food for a larger predator or scavenger. Or the leaf is buried and becomes part of the sedimentary memory. Ecosystems are made of such paths. Most are invisible. Some become fossils by accident. A seed takes another path. It falls near the base of a plant, or passes through an animal, or is carried by water. Some seeds are eaten. Some rot. Some sprout in fresh silt after a flood, where light reaches the ground and competition is lower. Disturbance opens space, and plants use it quickly. The same flood that kills animals can create germination surfaces. After the KPG disaster, this principle becomes global in altered form, devastated ground, pioneer plants, and slow rebuilding. But in ordinary Hell Creek nights, smaller disturbances already teach the landscape how to begin again. Fire may also have been part of the system. The Cretaceous world had oxygen, vegetation, lightning, dry intervals, and plant matter capable of burning. Charcoal in ancient sediments can indicate past fires. A nighttime fire on a floodplain would change every animal's movement, driving small animals from cover, forcing herbivores away from smoke, drawing predators later toward the dead or weakened. Fire is not always apocalypse. It can be disturbance, renewal, danger, and preservation all at once. After the impact, fires may have occurred on a far larger scale, but ordinary fire already belonged to terrestrial ecosystems. It is important not to place flames in every final scene just because the extinction involved impact energy. Hell Creek nights before the boundary were not constantly burning. Some were wet, some clear, some stormy, some dry. The landscape had variation. A balanced reconstruction allows flood, drought, fire, and calm without making any one process dominate every moment. The fossil record itself is patchy because the environment was patchy. Different localities preserve different parts of the mosaic. A mosaic landscape also means animals could move between habitats within a day or season. A hadrosaur might feed in open low vegetation and retreat toward trees. A Triceratops might use forest edges or more open patches depending on plant availability. Ankylosaurus may have preferred low browse. Tyrannosaurus could move through several habitat types while following scent, water, or prey. Smaller animals used microhabitats, under logs, in burrows, along banks, in canopy, in shallow water. Hell Creek was not one background repeated behind every animal. It was a set of options. Habitat preference is inferred from where fossils are found, associated sediments, functional anatomy, and comparison with related animals. But river systems can transport bones, mixing animals from nearby habitats. A skeleton in a channel deposit does not automatically mean the animal lived in the channel. A tooth in a microsite may have traveled. That is why context matters. Paleontologists ask whether remains are articulated, weathered, transported, sorted by size, associated with aquatic taxa, or embedded in particular sedimentary structures. The ancient night is reconstructed not only from what is found, but from how it came to rest. Rest is rare in the record. A body at rest leaves little unless death follows. Yet rest would have filled much of the night. Large animals cannot feed or walk constantly. Predators conserve energy. Herbivores pause between feeding bouts. Small mammals retreat to shelters. Birds settle. Crocodiliforms bask by day and wait by water at other times. A sleeping dinosaur is harder to imagine than a fighting one because it resists spectacle. But sleep, or something like it depending on the animal, was part of survival. Bodies need repair. A resting Triceratops lowers the drama of its horns. A resting Hadrosaur turns mass into stillness. A resting Tyrannosaur becomes less a symbol of power and more a breathing animal with folded limbs, scarred skin, and the vulnerability that comes with any body off alert. We do not know their exact resting postures in every case, but trace fossils and comparison can sometimes help. The broader truth is safe. Even the most formidable animals had to stop moving. Night would have held that stillness too. The stillness of a tyrannosaur would not make the landscape safe. Its presence might keep smaller scavengers at a distance if it rested near a carcass. Its scent could remain after it moved on. A trackway could guide or warn other animals. Large predators influence ecosystems even when not attacking. Modern landscapes show that fear can shape where prey feed, how long they stay in open areas, and when they approach water. Hell Creek likely had its own landscapes of fear, though the details are beyond direct measurement. The term landscape of fear should be used carefully in deep time, but the principle is straightforward. Predators affect prey behavior. Prey behavior affects vegetation use. Vegetation use affects habitat structure. Habitat structure affects other animals. This chain does not require constant killing. The possibility of predation is enough to alter movement and feeding. In Hell Creek, large predators, semi-aquatic ambush hunters, and smaller carnivores all contributed to risk in different zones. Night changed the distribution of that risk, not by making it greater everywhere, but by changing how animals detected and avoided one another. Along the channel, the risk from water may be as real as the risk from land. A small dinosaur approaching the edge sees reflected stars and dark surface, not the full shape beneath. A crocodiliform waits without needing speed until the final instant. The strike, if it comes, is not cinematic in the way a tyrannosaur chase is cinematic. It is a compression of stillness into force. Water breaks. Mud collapses. Then the surface closes again. Aquatic predation leaves fewer famous fossils but would have mattered greatly to animals near rivers and ponds. A turtle survives by withdrawing into its own architecture. A shell is not absolute safety, but it changes the terms of attack. Champsosaurs move with a different confidence in water. Fish occupy depths unavailable to dinosaurs. Amphibians use moisture and cover. Each body carries an answer to a question posed by the environment. What can eat here? What can hide here? What can reproduce here? What can endure when the channel shifts? Hell Creek is an exam written in mud and answered by anatomy. Anatomy, however, is inherited history as much as local solution. Tyrannosaurus did not invent the theropod body plan in Hell Creek. Triceratops belonged to a ceratopsian lineage with deep Asian and North American history. Hadrosaurs were the outcome of long ornithopod evolution. Ankylosaurus inherited armored strategies refined over millions of years. Mammals carried traits from synapsid ancestors. Crocodiliforms carried their own ancient success. The final Cretaceous world was a convergence of long histories meeting in one region shortly before a global interruption. That convergence makes a single night feel crowded with ancestry. A Tyrannosaur footstep contains Triassic beginnings, Jurassic diversification, Cretaceous specialization. A bird's wing contains the long transformation of theropod forelimbs and feathers. A mammal's tooth contains a separate story that began before dinosaurs dominated. A flowering plant's leaf contains the botanical revolution of the Cretaceous. Nothing in Hell Creek is merely present. Everything has arrived from earlier worlds. Earlier worlds are absent from the night, but present in bodies. There are no giant sauropods in Hell Creek like those of the Jurassic Morrison Formation. The herbivore community has changed. There are no stegosaurs at the river edge. The old plated forms have vanished from North America long before this final scene. The dinosaurs here are not generic dinosaurs. They are latest Cretaceous animals, living in a world with flowering plants, advanced hadrosaurs, ceratopsians, tyrannosaurids, ankylosaurs, pachycephalosaurs, birds, mammals, and a seaway withdrawing from the continent. This specificity matters because the Mesozoic was not one uniform age. The Triassic, Jurassic, and Cretaceous differed in climate, geography, plants, faunas, and ecological structure. Hell Creek belongs to the end of that sequence, not to the middle. Its animals are not the first rulers of the dinosaur age. They are the last great North American non-avian dinosaur communities before the boundary. Their world had inherited more than 160 million years of dinosaur evolution and was still changing when catastrophe arrived. Calling them the last great communities does not mean every part of the world looked like Hell Creek. South America, Asia, Europe, Antarctica, and other regions had their own latest Cretaceous ecosystems with different dinosaurs and different environmental histories. Hell Creek is famous partly because of its accessibility, history of collecting, and position near the KPG boundary. It is not a universal template, but it is one of the clearest terrestrial views we have of the end, and that clarity gives it a special weight. Weight returns us to the mud. A Triceratops foot presses down with enough force to deform sediment that will later harden. A Tyrannosaur step cuts deeper in one place where the bank is soft. A Hadrosaur track overlaps another, confusing the record before it even becomes one. The ground receives all of them without ranking. It does not know which animal will become more famous. It preserves what circumstances allow. There is a humility in that. A complete skeleton may come from a rare accident. A common animal may be poorly known if its habitat did not preserve well. A spectacular predator may be understood from more specimens than a small bird that mattered just as much to its own lineage. The fossil record is generous and unfair at the same time. Hell Creek's richness does not remove that unfairness. It only gives us more pieces with which to work. What did Hell Creek smell like after the first ash or dust began to fall from the impact plume? That question pulls us beyond what the local record can answer with sensory detail. But we can imagine the physical change: particles entering water, coating leaves, altering the surface of mud, moving into lungs and gills, changing the taste of pools. Animals would respond without understanding cause. They would shake their heads, seek shelter, drink from fouled water, or move through vegetation carrying a fine layer of material. Catastrophe becomes intimate when it lands on skin. Darkness after impact would not be a single night. It would be a prolonged environmental disturbance, with sunlight reduced and temperature patterns altered. Plants that depended on photosynthesis would suffer. Food webs tied to fresh plant growth would weaken. Detritus-based systems in animals with flexible diets may have had better chances in some settings. Large herbivores would face scarcity first through plants, and large carnivores would follow through herbivores. This is the quiet mathematics of collapse. Energy stops entering the system at the usual rate, and the largest accounts run out. Some freshwater ecosystems may have provided refuges because detrital food chains can persist on stored organic matter longer than systems dependent on immediate photosynthesis. This idea has been used to help explain why some freshwater animals survived the KPG extinction better than many terrestrial large-bodied groups. Hell Creek's rivers, ponds, and wetlands therefore matter not only before the boundary, but in thinking about survival after it. Water can buffer, store, transport, and shelter. It can also drown, bury, and erase. As always, the same feature of the landscape has more than one consequence. A turtle in water after the impact does not know it belongs to a survivorship pattern. It knows cold, hunger, shelter, and the need to breathe. A mammal in a burrow does not know its descendants may diversify. It knows darkness and smell, and the small radius of safety around its body. A bird that survives does not know it is carrying Dinosauria forward. It knows food, cover, and escape. Evolutionary meaning comes later. From the success of descendants, survival itself is immediate and bodily. That bodily survival is the bridge between the night before and the world after. The animals that cross the boundary do not cross because the boundary is symbolic. They cross by living through days when others die, finding food where others cannot, reproducing when others fail, and leaving descendants into damaged but opening ecosystems. The line in rock is sharp because the consequences are sharp, but the crossing is made by individual bodies. A lineage survives only because enough bodies do. For the non-avian dinosaurs, enough bodies did not. That is the final severity. Not one Triceratops population hidden in a valley. Not one Tyrannosaur line waiting out the darkness. Not one Hadrosaur herd emerging into the Paleogene. Claims of post-boundary non-avian dinosaurs have not withstood the broader scientific standard. The accepted record places their extinction at the boundary. The bones below remain abundant in places. Above, they are gone. The silence is not perfect in every local section, but globally the disappearance is decisive. Decisive does not mean simple to feel. A museum visitor standing beneath a T. Rex Mount may feel awe, fear, affection, curiosity, or sadness. The skeleton is both an animal and an emblem of extinction. But in Hell Creek at night, before the line, the animal does not ask for elegy. It asks only to be restored to life honestly, powerful, limited, hungry, alert, mortal, and unaware. The sadness belongs to us because we know the boundary. The animal belongs to itself. That difference between our knowledge and the animal's experience should guide the ending. We can place the asteroid in the story because scientifically it belongs there. We can place darkness after impact because extinction demands it. But we should not make the animals perform our grief. A Triceratops does not look up for meaning. A Tyrannosaur does not understand cosmic coincidence. A mammal does not celebrate survival. The floodplain absorbs the event physically, and life responds through biology. Biology is enough. A heart beats until it stops. A seed sprouts if conditions allow. A tooth is replaced. A bone heals. A track fills with water. A species continues if enough young survive. These plain facts carry more weight than invented prophecy. Hell Creek at night is moving because it was not trying to be moving. It was simply alive near the end. If we could stand there safely for only 1 minute, perhaps the most surprising thing would be how little the minute explains. We would hear sounds we could not identify, smell plants we could not name, feel humidity from a river system that no longer exists, sense the movement of large bodies without knowing their exact positions. We might not see Tyrannosaurus. We might not see Triceratops. We might leave with mud on our feet and no clear view of the famous animals. And still, we would have stood inside their world. Paleontology often works like that imagined minute. It rarely gives the whole famous animal at once. It gives a fragment and asks us to widen carefully. A jaw leads to a mammal. A tooth leads to a predator. A horn core leads to a ceratopsian. A layer of clay leads to a boundary. A pollen grain leads to a forest. Each clue is small until it is placed among others. Then the night begins to gather. When it gathers, Hell Creek becomes one of the clearest reminders that the dinosaur age ended not as an idea, but as an inhabited world. It had geography. It had weather. It had babies and old animals. It had rivers that changed course. It had plants growing back after floods. It had carcasses, dung, pollen, insects, birds, mammals, turtles, fish, and the last great non-avian dinosaurs of Western North America. The end matters, because the world before, it was so complete. Completeness is not the same as permanence. No ecosystem is permanent. Hell Creek's rivers would have changed even without the asteroid. Species would have evolved, migrated, declined, and been replaced. The seaway would have continued its retreat. Climate would have shifted. The Cenozoic would still have come in some form eventually, because Earth never stops changing. The asteroid did not introduce change to a static world. It accelerated change into catastrophe. Catastrophe is change faster than many organisms can absorb. A flood is catastrophe for animals caught in it, but the ecosystem may recover quickly. A drought can devastate local populations, but rains may return. An impact winter affects the base of food webs at planetary scale. The difference is reach and duration. Hell Creek animals were adapted to local disturbances. They were not adapted to the atmosphere itself becoming hostile to the rhythms that fed them. Under the last ordinary stars, those rhythms continue. Leaves open and close according to cycles. Insects emerge. Aquatic animals feed. Herbivores move between plants and water. Predators conserve energy until opportunity arrives. Small mammals use the dark as cover. Birds sleep or stir. The floodplain is not waiting, it is working. That work is what extinction will interrupt. A final way to understand the night is to follow the boundary backward instead of forward. Begin with the clay seam, the chemical signal, the absence above, and then move down into the dinosaur bearing beds below it. Each centimeter downward is not just depth, it is time returning to the ecosystem. First, the aftermath loosens. Then, the last signs of catastrophe fade. Then, the ordinary Cretaceous comes back into focus. Root traces, channel sands, plant debris, bones with no knowledge of what will later sit above them. Stratigraphy lets the mind descend from extinction into life. In that descent, the fossils regain temperature. A horn core stops being an object in a cabinet and becomes part of a skull carried through humid air. A tooth stops being a specimen number and becomes a cutting edge in a jaw. A turtle shell stops being a plate of bone and becomes shelter around organs. A mammal molar stops being a point on a faunal chart and becomes the surface that crushed food during a night of risk. Scientific naming does not remove life from these things. At its best, it returns life to them with greater care. The care matters because Hell Creek has often been treated as the place where dinosaurs wait to vanish. That framing is understandable, but incomplete. The formation is also the place where dinosaurs lived fully before they vanished. Its value is not only that it is near the extinction, but that it preserves an ecosystem worth understanding on its own terms. The end gives urgency, but the life gives meaning. Without the life, extinction is only subtraction. With the life restored, extinction becomes the loss of relationships. Those relationships extend into the ground itself. Roots break sediment and stabilize banks. Burrowing animals alter soil. Large feet compact pathways. Dung enriches patches of floodplain. Dead wood changes water flow. Fallen bodies attract scavengers and nutrients. A flood redistributes everything. Modern ecology recognizes these interactions as ecosystem engineering, nutrient cycling, disturbance, and succession. Hell Creek had the same broad processes under different actors. The names are modern. The processes are ancient. Succession would have followed local disturbance long before the KPG boundary. A channel abandoned by the river becomes an oxbow lake or wet depression. Plants colonize the margin. fine sediment settles. Organic matter accumulates. Fish, turtles, amphibians, insects, and small vertebrates use the water. Later, the depression fills, becomes soil, supports different vegetation, and may eventually be cut by another channel. Fossils from such settings can mix animals that lived in and around water across repeated episodes. A single outcrop can therefore contain a history of habitat change compressed into rock. At night beside an oxbow, the water is calmer than in the main river. The surface holds reflections longer. Mosquito-like insects gather. A frog call repeats from the margin. A small mammal moves along a fallen branch because the ground below is exposed. A crocodilian waits where the bank shelves gently. Farther back, a heavy herbivore feeds in the dark vegetation, close enough that its breath moves leaves, but far enough that it remains a shape rather than an animal. This is not the dramatic center of the world. It is one of the places that makes the world work. The word jungle is sometimes used casually for dinosaur habitats, but Hell Creek should not be flattened into a modern tropical rainforest unless evidence supports that exact image. It was warm and often wet, with forests, wetlands, rivers, and floodplains, but also seasonal variation and habitat mosaics. Some areas were more open, some were swampier, some were better drained. The correct image is not one wall of vegetation everywhere. It is a shifting coastal plain where water and sediment create different neighborhoods for different organisms. A neighborhood of higher ground might hold drier soils and different plants. A low swale might hold standing water long after rain. A levee beside a channel might support trees whose roots bind the bank until the river cuts them away. A backwater might collect leaves and small bones. Animals move between these neighborhoods because no single patch gives everything. Food may be here, water there, safety somewhere else. Night travel between them is part of the hidden life of the formation. Travel carries danger because movement reveals bodies. A young animal crossing open mud is visible to anything watching from cover. A predator leaving forest edge risks being seen by prey. A mammal moving from one shelter to another enters the scale of larger eyes. Even a giant animal can make a poor choice of ground. The floodplain is not a flat stage. It has soft pockets, cut banks, submerged branches, tangled roots, and channels that shift after rain. Locomotion is always negotiation with terrain. Limb bones record some of that negotiation in general form. The proportions of hadrosaur limbs indicate animals capable of substantial movement. Tyrannosaur hind limbs show powerful terrestrial locomotion, though debates continue over speed and gait. Ceratopsian limbs support heavy quadrupedal bodies. Ankylosaurs emphasize low, sturdy movement. These anatomical facts do not provide a map of one night, but they shape what each animal could plausibly do. Reconstruction should never ask a body to perform against its bones. The bones also carry the memory of gravity. Every large Hell Creek dinosaur was an answer to the problem of supporting mass on land. Vertebrae, hips, limb joints, tendons, muscles, and feet all participated. At night, when outlines soften, gravity remains precise. A Triceratops cannot place its foot like a bird. A Tyrannosaur cannot turn like a fox. An Ankylosaur cannot leap away from danger. The beauty of ancient animals is partly in their limits. Limits make them real. Limits also make the final catastrophe more understandable. No animal can evolve for every possible future. Hell Creek dinosaurs were adapted to their world, not to a sky filled with impact dust and a food web under global stress. Their failure to survive was not a failure of design in the ordinary sense. It was the arrival of conditions outside the range their bodies and life histories could absorb. For millions of years, they had been enough. Then, the world changed faster than enough could follow. Before that change, one last bank holds one last set of ordinary traces. A sliding mark from a turtle, a small three-toed print, a wide depression from a larger herbivore, the crushed edge of a plant stem, a tooth that no longer has a jaw, These traces do not know whether they are near the end of the formation or lower within it. They do not know whether anyone will find them. They are simply the leftovers of activity, and activity is the best evidence that the world was still alive. Even the word evidence has a night side. In daylight, evidence feels clean. A labeled drawer, a measured stratigraphic section, a published figure, a museum mount with every bone named. In the field, evidence may begin as a dark edge in bad light, a texture noticed before weather takes it, a fragment protected with glue because the slope is crumbling around it. Many Hell Creek fossils reached science because someone saw a difference between bone and stone at the right moment. Discovery is not separate from erosion. The hill reveals, and then it destroys if no one arrives in time. That urgency gives modern fieldwork its own quiet rhythm. Walk slowly, look close, mark the locality, record the layer. Do not pull a bone from context just because the bone is exciting. The position of a fossil can matter as much as the fossil itself, especially near a boundary where time is the question. A tooth without context is still useful. A tooth with context can speak more clearly. It can say where in the formation it belongs, what sediments held it, what other animals lay nearby, and how close it may be to the end. In that sense, the modern Badlands have their own version of night. Not darkness, but obscurity. The past is present and hidden at the same time. A slope may look empty until rain removes a skin of sediment. A fragment may be mistaken for a pebble. A microsite may seem unremarkable until screenwashing reveals dozens of tiny teeth and bones. Hell Creek does not give itself all at once. It has to be revisited after seasons, storms, and questions change. The formation is still being read because erosion is still turning pages. The ancient animals did not intend to leave those pages. They intended nothing beyond living. That is why the pages matter. They were not written for us, but they survived us into being able to read them. A print in mud, a tooth in silt, a boundary in clay, a bird outside the window now, each is a small connection across a distance too large to feel directly. Hell Creek at night is one way to stand near that distance without pretending to close it. One more thing should remain before the final image: the patience of stone. Stone does not preserve a world because the world was important. It preserves what chemistry, burial, and later exposure allow. Importance comes later, when a mind recognizes that a curve in the rock once belonged to a breathing animal. Hell Creek is powerful because so many such recognitions have accumulated, specimen by specimen, until a vanished floodplain has become visible again. The visibility is still partial, and that is why the night is the right doorway. Darkness admits incompleteness. It lets the animals remain partly beyond us while still close enough to imagine through evidence. We do not need to see every scale to know the body moved. We do not need to hear the exact call to know the air carried sound. We do not need the final individual to know the lineage ended. The rock gives enough. And enough is sometimes more honest than everything. In the final image, do not place Tyrannosaurus alone under a red sky. Place the river first. Let the water move through darkness. Let a turtle slide from mud. Let insects gather where a footprint holds water. Let a Triceratops pass beyond the trees without turning toward us. Let the Tyrannosaur remain mostly unseen, present as weight and scent and risk. Let the small mammal stay under roots. Let the bird shift once in its sleep. The world is ending, but not yet in this breath. The print at the riverbank keeps its shape a little longer. Silt settles inside it. The water clears. A leaf lies across the toes. Somewhere beyond the channel, a large animal moves away, and the sound becomes part of the dark. In time, the mud will harden. In time, the river will leave. In time, the boundary will fall above the last bones, and much later, under a different sky, someone will find the stone and understand that the night was once alive. Hell Creek remains in the rock, not as a complete world, but as enough of one. Enough horn and tooth, enough mud and pollen, enough turtle shell, mammal jaw, fish scale, and river sand. Enough to know that the last dinosaur world had darkness, weather, hunger, rest, fear, growth, and ordinary hours before the extraordinary end. The final days were not empty. They were full of life, right up to the edge where life changed forever. The riverbank is black again. Not empty black, not silent black. The kind of black that holds water, leaves, breath, and the shape of a foot in mud. The animal that made it is gone. The world that held it is gone. But the print, or the bone, or the tooth, or the boundary clay remains, and from those small surviving things, the night returns.